Hello everyone and welcome to C# 102. The journey continues. We have a few new faces in the class and a lot of people that were with us in 101. Your primary instructor throughout this journey will be Mr. Nelson LeCay. I, Jason Busby, will be joining in from time to time to add commentary on the side. Also, our TA is Mr. Gavin Whitlock. Say hello, Gavin.
Hello.
All right. So that's pretty much it. This is going to be a very fun course. If you are a complete beginner to C#, I would not suggest going through this course. You really need to do 101 first, because this class, even though it's designed as a 102, Nelson and I have been on and off discussing the syllabus, and this is going to probably bounce between 102, 103, and 106. I don't know. This class will become a little bit challenging for some of you, I'm sure. But we are here to work with you guys. We will make ourselves available for open office hours. Generally on Wednesdays, I'll try to do rotating times to help those of you overseas. If you're having trouble, please, I beg you, try to join in to those free times that we make available to you, and let us help you. I mean, you can get some one-on-one help. You know, well, I mean, there's people watching, but it can be one-on-one. One-on-one help. If I can speak straight, that'd be great. All right, let's see. Anything else that we need to talk about real quick? Because I know this is night number 1. I can't really think of anything other than for those of you that are joining us for the very first time, please make sure you're in BuzzNet. Night number 1, I'm not bad about. Next week, I will be bad about it. If you're not over in BuzzNet, 1, you definitely don't get credit. So if you want credit for the attendance, you need to be in BuzzNet. Number 2, BuzzNet is, for those of you that are now asking over in the questions panel, take your browser and point it to the address buzznet.3dbuzz.com. And Nelson's bringing over a screenshot of it, though it does look a little bit different because we're able to monitor what people are doing. And we have about 20 more people in the webinar that are not in BuzzNet at the moment. So join us in BuzzNet.
Or suffer the retribution.
Yep, and just a quick overview, we have the participate button that you can click if you want to be participating. Then you can cycle through 1 minute ready and not ready, and we can reset that at will. And the idea is that we can gauge where people are when they are participating or typing out code alongside us.
And this is very important. So if we ask you guys to follow along with something and you're participating, you have to hit the participate button. All of this information gets recorded for us, so we're able to tell which students participate in the class later on, and that's very handy for us. We encourage everyone to participate. If you are going to go away from your keyboard, just hit the participate button again. It will simply remove you out of the colored list and you will appear at the bottom of the list. That way we're not sitting here waiting for someone. See, if you scroll down, Nelson, we can see people that are over there that are not participating at the moment. So please, just make sure to unclick the participate button. How do you unclick a button? Just click the button again so you're not participating, and that will be good. And Brian, hopefully that will answer your question, sir, about what happens if you have to go away. Calendar, very important. I know I preach this all the time, and I guess I need to continue preaching it at the beginning of, day number 1 of each new class. Please make this a link that you go to often. On the live classes calendar, this is where everything gets posted. As new classes become available, registration links will appear in here. But the most important thing for you guys, there's 2 things. 1, password. The password always shows up within 5 minutes before class start. I say within 5 minutes because sometimes it might be 2 minutes before. But as you guys know, we give a few extra minutes for our stragglers to come into the class, so it's not like you're going to miss something if it's 1 minute before 7 o'clock in this case that the password gets pasted. So that's 1. Number 2, homework. As homework is assigned, and there will be loads of homework in this class, there will be a link that will be available generally within an hour after the class is over, as Gavin gets everything all typed up. And you can simply go into the calendar, click on the homework link right there. It'll take you to the thread, and you'll have homework details there. Also,
Well,
videos. Let me say this real quick because we'll go over more homework stuff at the end. But as each class ends, I get videos encoded as quickly as I can. I make them available on 3D Buzz for you member sponsors. The easy way to find those videos is simply come back to the calendar, locate the class that you're interested in watching the video for, and click the Watch Video button. It's as simple as that. Okay?
could you just, while you're there, show them the main homework submission rules thread that explains about getting set up?
Oh, can we?
I wanted to. Oh, okay.
I really want to spend the bulk of time dealing with homework at the end. I just want to get the preliminary introductions and the overview of BuzzNet and the class calendar out of the way. So
and I do want to point out that you must be logged into a member sponsor account to see the registration and passwords and homework.
That's correct.
And videos.
Okay. The only other thing I would like to point out is that if you have questions that you would like for us to answer, please put them in the webinar questions panel. You are welcome to put questions over in BuzzNet. And from time to time, if we see those questions go scrolling by, we may jump in and answer them. But do not expect us to. That's very important. If you want us to answer them, put them in the questions panel. For those of you that don't care who answers, you can toss the question over in the BuzzNet. We have a lot of amazing members that are joining us that will simply jump in and answer the question for you. People like Segfault, really, really quick at stuff like that. So you're welcome to use it, but just keep in mind we're not constantly monitoring BuzzNet as far as chat goes. We're more interested in the participants and watching that information in BuzzNet and then watching the questions panel. All right, I think that's about everything. We have a lot to do tonight. So Nelson, I do believe that we said we're going to start things off first with a little bit of a talk about what the course as a whole is going to try to achieve, and then we have a little review to go over tonight to get things kicked off.
Okay, so basically this class is all about objects. It's all about object-oriented programming. It's not going to go into too in-depth object-oriented programming. We're going to be using some simple facilities that are provided to us by the C# language. We aren't going to get into design patterns, although I reserve the right to digress at any point into design patterns.
I'm sure it's going to happen.
For a short period. So don't expect anything, that intense. But we are going to be talking about objects, classes, inheritance, interfaces, polymorphism, encapsulation, and all that stuff. We're also going to be covering a lot of the BCL in this class. I want to start being able to use in the class a lot of the features that the C# or the .NET framework provides us. So we're going to be going over some more file input-output, some more collections. We're going to be going over IEnumerable, iterator blocks, IDisposable, and all that stuff. We are also going to be going over some design discussions. We're going to be going over what's kind of been coined as the main object-oriented sort of principles that have been combined into something called SOLID. And we're going to be going over each one of the principles defined under SOLID in each one of the courses. So all 5 weeks, first 5 weeks, and then the last week we're going to be going over a few other terms. So we're going to be going over object-oriented design to an extent in relation to SOLID, some new BCL, new techniques, and most importantly, how we can use objects, classes, interfaces to produce interesting results. Now, the goal of this class is to basically put together a little RPG text game. Now, I really wanted to have a demo of that for everybody to see in the first class, and also to have some, some basic data available that people can start plugging into their games as they continue to build them. But unfortunately, there has been a bit of a,
BuzzNet needed to be rewritten for the last few days.
Yeah, there's been a lot of work going on. So I started on it today. I put about
Put a few hours into it, didn't you?
Yeah, or bus game.
Did you lose it?
So I put a few hours into, or about an hour and a half into putting together a basic structure of how I kind of want to see the game going. Right now, the actual game is very straightforward. So, we're in a basic room now, and we can move north, and we are now in another room, and now we can move back south to get into that room. So basic stuff at the moment, but this interface and this game is going to be built on throughout the class. And next class, I'll have a actual real demo of all the features that we're going to be building.
Well, let's talk about what kind of features do you have in mind?
You spelled invalid wrong, by the way, in invalidcommand.cs. Hey, that's what I'm here for.
Okay. Well, the features that I definitely want to support are going to be, first of all, moving between rooms. That's going to be obviously the most basic feature of an RPG text game. I want to support the ability for an inventory as well. But most importantly, I want things to be extensible to the point where we can write some custom code for particular rooms and get rooms to behave differently depending on how many times you've entered them, what you've done in the rooms, and so on. So I want to support maybe a basic concept of other creatures. I don't necessarily want to get into like a combat system, but just having, being able to represent your health bar, for example, and inventory items that affect that. And I also we're going to have a basic text format that we're going to be using to load the game and be able to edit the game outside of the actual game runtime. So as you see right now, I'm just instantiating a few objects and setting them up manually. But when everything is completed, this will all be loaded from a file, and that file will be allowed to use the functionality that you've built into your engine to arrange things in whatever way you want. So, for example, you'll notice I only have a basic room class, which is a very, basic room. But there's nothing stopping us from writing another room class that could have maybe a creature or a timer or something like that you'd be able to use the file API to configure and load up for your individual games. So,
okay, cool.
I mean, is there anything else that would be interesting, or?
Well,
that's what I had in mind.
A creature that's an entity of its own that can, through your turns of moving from one input to another, be room to room or picking up items or whatever, it could, move from room to room as well.
Bit of AI.
Well, very simple AI. I mean, the class isn't
cool
to be focused on that, but it would not be. It'd be very simple to add in. Heck, we could just talk about it in design when we get a little bit later on into this class, and then just have people just make that as a homework assignment.
We could point at Logan's very, very good behavior system videos.
Yeah, but there's no need to go that involved.
True.
I mean, because it's not like we're going to go in here and lay down a path network and do a star for,
Did you see what Ironsoul put into BuzzNet just then?
Oh, what was that?
We should have a game competition after we finish learning all this stuff. We should totally do that.
Yeah, that'd be a lot of fun. It'd be a blast. Come up with some sort of really cool prize for first, second, and third place. Yeah, I'm down with that idea. I like it.
Brian actually asked a question that we will be going over in this class, but I just want to point it out. Why do I have this I convention? These are interfaces, and we are going to be talking and using and talking even more about interfaces a lot in this course.
Nelson loves interfaces.
Well, it's time for us to start getting into some more serious design, and that interfaces play a very important part of software design, as you guys will see.
Yep. Cool. Make me a game, Nelson.
No. We need to do the review. That's part of the syllabus. We need to.
Oh, but
come on. We can add stuff, but I don't like taking stuff out. So we got to do a review for people that may have gotten a little rusty over the past week, and then we're going to jump into some cool new stuff.
hold on, my VM is taking a bit to spool up here.
I should just say lol at Saturn 2226.
I'm not a buzzkill. Thank you very much.
That's hilarious.
Hey, look, I was the one
To
that
answer
was
your
wanting to
question,
start.
Saxon?
I was the one that's wanting to start putting creatures into the game. Come on.
Yeah, that
Oh
should
no,
be.
I'm really cool with that. I like that idea.
Sackfall, to answer your question, nobody knows. Okay, so yeah, let's do a review. So this is, to people who are not familiar with this course, the way we've been doing things, this is the little VM that I put together that just has the, and I just broke it.
Good job.
This
It
is
just
a VM
has
I
all these
use
pony
forever.
pictures on. Yeah.
Now my mouse is locked.
Have you ever used a computer before, Nelson? Just checking.
Well, once my VM decides to come back up, there we go. But now it's in the improper resolution. You really are being obnoxious. Autofit guest. Come on, autofit it. I've never seen a VM fail this hard before. Okay.
I see
It's a feature.
some of it.
Actually, if you want to pause the video, I'm going to go ahead and restart my VM.
All right. Okay, we're resumed.
Okay, so yes, this is my VM, and I'm going to be using an install of Visual C# 2010 Express for everything. So if you guys are using Visual C# 2000 or Visual Studio 2010 Professional or Ultimate or Premium or whatever those editions are called, then that will work just fine as well.
No, ReSharper's not going to work with Express.
Nope.
And I still would like for us to have a one-night member sponsor class for anyone that wants to join, or daytime, and do a ReSharper thing. I would really like for us to get back to where we're using, Pro and ReSharper, because it just makes life a lot easier.
Yeah, but the thing about
ReSharper is just the best thing ever.
But the stuff that I use ReSharper to do, sling around classes like really effectively and quickly, it would be too, I think, confusing for people who
Right now it
don't.
would. It would.
Yeah.
It enables him to actually create a class and close it in one frame capture at 10 frames per second.
Yeah. Okay, so let's go ahead and review some basic things. So, first of all, let's talk about variables really quickly. After Monday, that feels so nice.
Yeah. Enjoy it, because C++ kicks back off again tomorrow.
Oh, come on. Fine, save it. Okay, so we have different variables, and variables are nice objects or variables are just ways for us to, well, modify data during the execution of our program. Every variable has a name, every variable has a type. Type determines what functionality that variable has on it. It determines what valid values can be stored within that variable. So, for example, unlike a certain language I know, this is not possible. And the reason is because that's the type checking. This is a integer literal. This is a Boolean variable. A Boolean dictates that only certain types of values can be accepted. So, yep, those are our variables. Now we can print out our variables. We can input our variables from a variety of sources, and then we can further change them to whatever we need to, and again, print them out again. No, never mind. This returns void, doesn't it? So, straightforward stuff. Any questions about variables? And this is just going to be a very cursory overview, because everybody should be pretty comfortable with these concepts as of right now. Okay, so moving on, we have conditionals. So we have if, and then we can specify a Boolean expression inside the if's parentheses, and that will conditionally execute a block of code. We have else statements. Else statements are statements directly precede or after an if statement that will execute if the if is not true. So as a result, you see that the proper if statement is valid or is evaluated to true. And of course, they become more interesting when we introduce actual input in our expressions. So very straightforward concept. What do you think about Barry's question, Jason?
Yeah, go ahead and mention it real quick.
So we have ifs, we have elses, and we also have else ifs. Else ifs are just elses with a if on them, not surprisingly. So as a result, right here we have a else block, but then immediately after the else block we have another if block that's going to execute only if this condition is true. So now if we put in 3, we get whoa. If we put in 6, we get that. And if we put in 11, we get that. Alrighty, loops. We have a different variety of different kinds of loops. Most simple of them is going to be the while loop. So while index is smaller than 10, index plus plus, console right line, I is, and if we run it, we get this nice output. So straightforward, we have the while loop that allows us to loop while this condition continues to be true. And as a result, we need to, in some way inside of the loop, make it possible for that condition to at some point be false, because if I were to comment this out and run this, you'll notice that, well, it never terminates.
Also, Nelson, you might want to slow down just a tad. When you're jumping into those console screens, some people aren't even able to see them come up and down because you're just opening and closing them real quick.
So, yeah, there's the output of this program.
Doesn't need to be that long, just longer than a frame.
Yeah, no, I was looking over past that. I wasn't trying to be a smartass. Okay, so that's our while loop. And if anybody has any more questions about this stuff, hopefully everything that I'm showing is incredibly simple for people. But if people are just joining into the class who didn't attend the 101, then that might be an indication that we have, yeah. Okay, so for loops. For loops have 3 parts: the variable initialization, the condition, and the action. So we have the variable here, int I equals 0, the condition, which behaves just like a condition within a while loop, I is smaller than 10, and then the action that's performed at the end of every for loop, which is I++. So now we can simply write I is I, run this, and you'll notice we get 2 0 through 9s. Can I declare a variable within a condition statement? You cannot declare a variable inside of the parentheses. If I were to say int I equals 10, this would be invalid. But you can declare a variable within the block. So if you wanted to declare a variable in the block, you're more than welcome to, but you cannot declare a variable within the parentheses of a conditional.
If you do declare a variable within the conditional, it of course will only be available within that conditional.
Yep. So if I were to try to access I right here, you'll notice that there is no I object or I variable because I was defined in a scope that isn't accessible by the parent scope. Okay, for each loops. For each loops are really useful when dealing with arrays. So if I have an int array, can now loop over it with a for each loop. Very nice looping construct that will behave similarly for, oh, go away, for lists as well. So if I were to say my list dot add 10, 11, 12, 13, I can do the same thing. So as you see here, we have two instances of a for each loop, but both are enumerating over different types. In this case, we're enumerating over an int array. In this case, we're enumerating over a list of ints. What's that funky
Were you not in the 101 class, Robert? Because we had a night that we specifically talked about formatting.
Well, I can do a brief overview.
Oh, Robert, then you really need to watch the 101 class videos, because I don't want us to get... No, he's more than welcome to join, but we can't... We have to be very careful not to put us in a situation to where we're spending more time with 101 concepts. I've been there. I've done that with classes before. We can't do that. So you
I know,
give the
if
quick review.
If this is the only question so far, then that's...
Right. I just want to point out he needs to get caught up. It's very important.
Okay, these are used as placeholders in string formats, and console.writeLine accepts an overload with a string format. So by specifying 0 within these curly braces, it's going to replace the placeholder with whatever variable that corresponds with that index. Okay, can you remind me, can you modify the contents of a list while looping over it? No. Well, yes, if you're using a for loop, you can. If you are using a for each loop, you cannot. There's a very, very good reason why that's not possible. So if I were to say my list.add 10 right here, you'll notice I get a nice little exception. Collection was modified, enumeration operation may not execute. That's very important.
Did you cover the for loops, the decrementing for loops in 101? I can't recall.
Yeah, we talked about that.
Reverse fors.
Yeah, we talked about they can increment and decrement.
Cool. I was just thinking, because if you remove something from a list, it's going to explode otherwise.
Yeah. NATO, you say you're still hazy on for each loops. Any particular questions about for each loops? I mean, is it just the syntax that you're not remembering, or is it something more conceptual?
Nah, what?
NATO.
Oh,
NATO.
Waiting on NATO.
Item in that for each loop is a generic item and not a type. Yeah, this is a variable. We are actually declaring a variable inside of these parentheses by saying int, which is the type of the variable, item, which is the name of the variable, and then specifying using the in keyword, which is only valid within for each loops, and then specifying my list as the collection we're enumerating.
It's a good point to review decent naming conventions.
And Robert,
Yeah,
no, you don't have to submit 101 homework. Just that, not until the 101 class comes back around. But I would just highly recommend going through the 101 videos so that following this course will be much easier. Sorry, continue.
Getting a for each loop to output two lists, you're not going to be able to do that simultaneously. You're not going to be able to enumerate over two lists at the same time. What you can do is use a nested for each loop, but that's going to give you the Cartesian product of both of those lists, meaning that you're going to, if you had the items 0, 1 in both of the lists, you're going to get 0, 0, 0, 1, 1, 0, 1, 1, which probably isn't what you're looking for. So you're going to have to use a for loop if you want to loop over two lists at the same time, or use this LINQ, but we haven't gone over LINQ.
And also, Benjamin had a good question for you over in the questions panel.
Case specific, but I use Unity 3D, and I don't think right-line arguments, the curlies, work with debug.log. Is there an alternative syntax to get around that? Well, certainly. You can just default into string concatenation, where you could say console right-line, my number is my number.
Well, you better show string.format, or I'm getting a ticket to come up to Seattle and kick you in the...
I was going to.
Okay.
Jeez.
I was like,
string
do that?
String concatenation is day one of C# 101. We're done with that. Come on.
Yeah, but did you hear like the inflection when I said you could do this?
No, I never listened to what you say.
It was supposed to lead up to...
So what you're saying is I'm about to show you a bad way of doing this, so please ignore it.
So you could do this, but the preferred way is if you want to pass in a string, a format string, into a object or into a method that accepts a string but not a format string, you can simply do string.format. And string.format will behave like what you saw before. So we could say my number, and then my number. Now with WriteLine, because WriteLine understands format strings, you don't need to do this with WriteLine. But for debug log, which does not understand format strings, you would have to wrap it in an invocation to string.format.
And with the question that was just asked from Iron Soul, this is a C# 102 class. String.format is something that was also talked about in 101.
All right. Can you make a method to iterate through a for each and call that method within the for each? Can you make a method to iterate through a for each, call that method? Can you make a method to iterate through, call that method within? I don't understand. Not a question but a comment. Loving the Michael Nelson tonight. Oh, well, that's nice. I didn't mean that in a sarcastic way. I actually meant that in an honest way because people have been complaining about my microphone for like the last 4 classes. Let's see. My microphone is ugly. That's not very nice. Okay, so David, yeah, you're going to have to use a for loop if you want to iterate through 2 collections simultaneously. So, yeah.
So now a quick review of our methods.
Methods are a way to create blocks of functionality that you can name. So for example, I could create a method called doStuff, which will print out doing stuff. And then I can invoke this method as many times as I want to. And you'll notice that I get doing stuff 3 times in a row. Methods can also take in parameters and return values. So for example, I could say a method called getInt that takes in a string prompt, and I can say console, I could just say while true, console WriteLine, how about just write prompt int input if int.try parse console read line out input return input, otherwise say console WriteLine invalid input. So now that I've grouped together this piece of code that you might be requiring multiple times inside of your program, I've now named this functionality and am able to invoke it from anywhere. So I could say int age equals getInt age. I could say int stuff equals getInt stuff. And now you see that I can reuse that functionality as much as I want and get a return value from that. Is a method in C# equivalent to a function? I hate that focus issue. It's driving me insane. Well, certain languages only call things functions, like PHP, where functions outside of a class are still called functions and functions inside of a class are still called functions. Other languages like C++ will name functions within a class member or methods and functions outside of a class functions. In C#, it is not possible to create a function outside of a class, and as a result, everything that you would be creating a function for is actually going to be a method.
That's correct. And methods can return data.
Huh. I've never heard it put as concisely as that before.
Yep, but that's...
I knew they were vaguely synonymous, but not quite. But excellent. Thank you.
Okay. All right. Are there any questions about functions? And in Visual Basic, if I'm not mistaken, aren't procedures method functions that don't return something and subroutines functions that do return something?
We're starting to talk about, like if you start getting into, like in Mel for Maya, procedures can be thought of like methods that don't return anything, where functions are going to be like methods that do return something. You know, it depends on what language you're talking about. But since we're just dealing with C#, we're just dealing with methods, and methods can return void or data.
Okay, so any questions about functions? Visual Basic is
You mean methods?
Methods. Those are what I'm talking about. Well, no, someone, Iron Soul said Visual Basic is a very obtuse language, and yes, it is. Okay, so any questions about methods? No, we did not cover ref and out in 101. And C# actually isn't a purely object-oriented programming language. And the reason it isn't is because null is not an object. Neither is void. Those are two values or things that you can use that are kind of like values that aren't objects. In a fully object-oriented programming language, null would be an object itself. But it's very, very close to that. Okay, so I guess there's no questions. All right, so moving on to classes. So what's a class? A class is something that we're going to be talking a lot about in 102. And what a class is it's a template, a way to define how an object will behave. So an object, remember, an object is basically every variable that you have in C# is an object. And an object has data that it contains, and it also has behavior that it exposes. So for example, if we were to create an integer, which is an object in C#, it's not an object in all languages, but it is one in C#, you'll notice that not only contains values, which in this case it can only contain one type of data, but also has behavior on it. The only real behavior that's interesting is like toString and compare to, and maybe get hash code. But yes, so objects are variables essentially, but in order to create our own custom objects, we need to define a structure for those objects that we would create. A class is the way in C# that we do that. Again, a variety of ways and a variety of different languages that we can go about defining what an object is, what state it contains, and what behavior it is responsible for. But in C#, we use the class construct in order to create a blueprint for an object that we might be able to use later. So for example, I could say class person. I could say public string first name, public string last name. Then I can give it some behavior, like public void display. So now if I were to use this object, I could simply say person p1 equals new person, p1.firstname equals Nelson, p1.lastname equals okay, and then I can say p1.display. So now you see that we have essentially templated out an object that we can reuse multiple times. And if I were to run this program, we get what we expect. Can there be a class construct? I'm not sure I understand that question.
I assume he meant constructor.
Oh, yes, there can be. I was about to get into that. Okay, so we have this stuff, but classes really are more important in C# than really anything else. And so as a result, there's a lot of features we can use in classes. One of the features is, let's say we want to disallow altering our names after a person has been instantiated. So we can simply say, turn these guys into automatic properties with a private setter. As a result, lines 24 and 25 become invalid because you cannot assign to a property that has a private setter. But what we can do is we can create a constructor that will replace the default constructor and add in the two parameters that are required in order for this object to be considered legal. So now our code, instead of being this, becomes simply that. Can you overload constructors? Yes, you can. So, for example, we could have a person with, first name and last name, and we might have a default constructor that says first name equals invalid in all caps and last name equals invalid in all caps. And then we can say, okay, well, let's say person P2 equals new person, say P2.display. We will get what we expect, invalid, comma, invalid. So that's an example of overloading the constructors. Okay. Any other questions?
Static? Did you?
We did talk about static in the very last class.
It's not a bad idea in this particular case to go ahead and spend a few minutes talking about static for real now.
Okay. Is there a protected type? Yes, you can have protectedness, but obviously protectedness only makes sense in the context of inheritance, which is one of the major things we're going to be going over later in the class.
Yep.
So, okay, staticness. Staticness is a way to create a variable or a field or it's a way to create a member, which could be either a constant, a field, or a method or a property. And well, yeah, or you can define a static class within here. But the main thing about what static does is it makes it shared between all instances of this type. We have effectively declared a global variable. Because inside of here, as of right now, class person doesn't in itself contain any data. This thing doesn't exist. This thing doesn't matter. This thing has no data, no memory allocated for it, just the thing that's there. And we use it by instantiating it and creating objects out of it. However, you could also use the concept of static to create effectively what's called a global, meaning that this variable is now a part or a member of the class, and there's only ever one of these available to us, and it's the same no matter where we're accessing it from. So now you notice that on line 20, every time a person is instantiated, and I'll do that in both the constructors, every time a person is instantiated, we increment our number of people variable. So now down here, after I instantiate 2 people, I can say console write line person dot number of people. And if I hit F5, you'll see 2 down there. Of course, this is not this is not a recommended use of staticness because there are a variety of reasons why we might want to count how many people we have. And doing so at this class level really limits the flexibility of doing those counting calculations. For example, what if you wanted to count how many people had the name of blah, for example? In that case, you would be forced to not use static. I mean, you could do this. But this would be absolutely horrible. Because using static in this context, making a computation that's shared between the class or all instances of the class will ultimately lead you to creating very difficult to understand code.
Plus, what if I, as your client, come to you and say, "Oh, now we also need to keep track of the number of people named Woe"?
Right. Then we would have to add another member and blah, 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 and it would just get really obnoxious. Instead, we can do those computations elsewhere. We could add all these people to a list and then simply perform the computation of what the client wants as needed.
I was just going to say, you have actually got a good example of when you might want to use static there because ReSharper did it for you in your getInt method.
Oh, right. The getInt method is something that you would generally want to use static for. When you have a method that is pure, well, actually, this method isn't pure. Sadly, it isn't. So for sake of, I guess I can't say that it is, but it is conceptually staticable because it really...
Ooh.
It returns a value and takes an input. It does not depend on external state. You can argue that it does because it accesses console write and console.readline and console.writeline, which technically do impact or alter the state of the program externally. And it isn't pure because it doesn't necessarily return the same result every time. That being said, the attributes that make this a good candidate for being static is that it doesn't depend on any other member of any other class other than other properly static methods such as .write, .readline, .writeline. So it's very self-contained and it makes it a very good candidate for being static.
Basically, it's always, I mean, it's there in the title, it gets an int. So it's always going to be used in the same way as the key. It's not something that is going to be changed.
Right. If it did alter some sort of external state, then I would be very tempted to make a class out of this and store the external state and encapsulate that external state in your own class. Because then once you start having static methods that alter state, you run into a situation where if you try to reuse that same code for different purposes, you'll run into a situation where you have to copy and paste your code so that references different variables.
Cool.
So something be a vehicle with a few variables like can move be a good candidate for static? No, not really, because a vehicle is really a class. It's really an object that you would want to interact with. You would want more than one vehicles in your program. Because right here with static, you can only have one thing that's declared static in your program. We can only have one number of people. We can only have one number of people with name of blah. A vehicle, you would want multiple instances.
From my perspective, static is one of those things, particularly with classes as well, that it's difficult to see why it's bad at first, and it seems more useful than it is.
Yeah, it's effectively globals, which have always, in the history of programming, been what people generally gravitate to before they actually start realizing that typing a little bit more code to avoid using that feature makes their code more robust. Okay, are there magic methods for classes in C# like in PHP? What he's referring to is in PHP there's a magic method that allows you to intercept. It actually looks like this. It allows you to intercept a method invocation on a method that doesn't exist in C#. But this is not, well,
in PHP.
You what? Well, yeah, no. I was going to say this is not possible in C#, but it kind of sort of is.
I was about to say, yeah, it is.
Looks like a delegate.
Well, what this would do is this would say if I typed in p1.ble, then this would intercept that invocation. But because C# is primarily a statically typed language, this is impossible. You have to have all your members defined on your objects if you want to use them. That being said, this will compile. This uses what's called the DLR, which gives dynamic typing capabilities to C#, but we are definitely not going to be talking about the DLR.
Is that we do not ever expect to see that keyword again?
I really want to get into talking about the DLR at some point, but that's like a 600 series course. You know what I mean?
Okay.
But for those that are in the MMO class, that's the very next thing that we have to record.
Yeah.
Which is pretty funny.
Okay. If we only use one class, should it be static? No. Unless the candidacy of an object or a class to be static should not in any way reflect how many instances that you want of that class. There are things that are good to be static, but just because you have one class that has one member on it that you never instantiate another object of that class, that doesn't necessarily mean it should be static. Now, it might be static in its own right, or it should be.
No.
It maybe should be static in its own right, but not just because of the amount of instances you have of it. Because in programming, we really want things to be reusable and repurposable while we code. And by typing in the word static anywhere in a C# code file, you have instantly limited the amount that you can reuse a particular bit of code.
Yeah, but with some things, such as a math class that's going to contain algorithms that would never change, sine,
Right.
cosine, power of, square root, that is a really good example of something. Those are pure methods.
Yep. And yeah, anything that's pure really should be static. Anything that's pure, as in it can take parameters, it can return results, but a pure method cannot in any way alter the state of the program. It can have no side effects. Unfortunately, this is close to a pure method, but it's not quite because console.write technically does alter the state. But something like cosine is pure. So static is a method like consist to a variable. Yeah, that's
an interesting way of looking at it, but kind of.
Pure returns a variable and nothing else. Essentially, yes. Think about it this way. Here's a kind of inside-out way to define a pure method or a pure function. A pure function or pure method is a block of code that, given the same input, will always return the same output. And it's to fit that criteria, it has to be mathematically provable that, given the same input to a pure function, always returns the same output. That is what a pure method or a pure function is. And that's why this isn't, because, well, it returns console input. So that can change. Yeah, if you have a method like this, this is pure. It does not in any way rely on or mutate external state. The only variables it's allowed to use inside of execution are the parameters, and the only thing it's allowed to use to talk to the rest of the world is its return. Okay, and once we get into more like functional concepts and maybe the next or the one after the courses here, especially once we start talking about LINQ and all that stuff, and delegates and lambdas. That's where stuff like whether or not a function is pure becomes very, very important to be able to distinguish.
Right.
Because using a non-pure method in a deferred execution environment will cause you miserable headaches. Okay, well, is that it for the review?
Yeah,
because
any more questions? Because what we'll do is we'll take a break, because then we're going to start off with new syntax for tonight.
Did we go over the string array? We did not. We have not touched the string array that is passed into main.
And that's something that we can cover later. I mean, it's very simple stuff. It's just nothing that we need right now.
Now, static doesn't necessarily mean unchanging. It kind of does in a different connotation of the word, I suppose. But as you see right here, these variables are static and they can change. But the variables, this is getting confusing. The values of the variables can change. The variables themselves are always the same.
It's like Highlander. There can be only one number of people. Hey, I always remember that. I don't know when it became associated in my head, but I think you must have said there can be only one at some point. It just popped into my head.
I've only seen the quickening.
All right, Iron Soul. All right, guys, let's go ahead and take a 10-minute break, and we'll meet you guys back and get going. Okay? So 10-minute break. I'm going to go ahead and pause the video and see you guys in a minute. One. And we're now back from break. Welcome back. Let's continue.
Code.
The end. Thank you very much.
Okay, so is everybody good, feeling good about the review?
That's right, because it's time to get into the cool stuff, finally.
Team.
Inheritance, virtual members, override versus new, abstract classes, members, and interfaces. Let's do it! All right, Nelson, let's get started.
You still need Rocky IV to start playing.
And remember, Nelson, we definitely want to get student participation with some of these things that you're about to get into now.
Alrighty. So far we've had classes. And we've had classes like person. And we've given person some properties, like first name. I'm just going to do get set at the moment. And then like last name. And it's cool because, you know, we have this awesome person that we can kind of pass around. Places. So for example, we could have a method called like static void print person, which could even be on the person type itself, where we could go ahead and print out that person. So derp. So it's nice and fun and cool and stuff, but this using classes like this is straightforward, but we can do better. We can make code. We can architect code in a way that provides us a lot of awesome advanced functionality by using just a few different new concepts that we have available to us in the C# language, and in fact in a variety of object-oriented programming languages. First one that we're going to be talking about really quickly, or the first one we're going to be talking about in depth, and it won't end up being very quick, is inheritance. So, inheritance is a way for us to write a class that we can inherit, or we can inherit the functionality of a class above it, the parent class. And we do so with this awesome little colon symbol, followed by the class we want to inherit from. So essentially what I've done is I've created a new object template called employee. And I've instructed the C# compiler to treat an employee as if it was a person, but with as many additional members as I might want to put on it. For example, I might want to place public int salary. So that employees have salary. Or how about yearly income? So I don't cause Gavin to throw a fit. So what we have here is we now have a different object template called employee that inherits all the functionality from person, but adds some additional functionality for us. So for example, if I were to now go ahead and write employee Nelson equals new employee, watch what happens when I hit the dot keyword. So note, we are instantiating a new object. We're declaring a variable named Nelson of type employee, but when I hit dot, you'll notice something interesting. We not only get our yearly income property, but we also get first name and last name. First name and last name are inherited from the person class. So I can say first name equals Nelson and Nelson dot last name equals LINQ. And then I can also say Nelson dot yearly income equals 10. So what's going on here is we are adding data to this object from two different places, from both the person and the employee. And an employee is still considered to be a person by the C# compiler. Somebody asked, what happens if you do person inherits from employee? You're going to get a nice little compiler error. Circular base class dependency involving employee and person. Anyway, so our employee is actually the same. It's very similar to a person. In fact, it can be used in the same places that a person might be able to be used. For example, we can pass it in to print person. So that's at a very basic level of what inheritance is. And inheritance is used to create classes that share functionality. That being said, I really, can you do person else equals new employee? Yes, you can. Now watch what happens when I change the type of the variable. I can say person Nelson equals new employee, but look what happens. Line 32, we get an error. That's because we are casting, well, implicitly casting the type employee into person because of this assignment right here. Because we're assigning an employee instance to a person variable. Although this technically still is an employee, we are accessing him as if he was a person, meaning we cannot access any of the additional functionality that we placed on that type. Can you override first name member in employee? Yes and no. That's going to be, we're going to be talking about virtual members here pretty soon and the new keyword. Can you inherit from two classes simultaneously? You cannot. C# is like many other languages, PHP, Java, and then for some reason I can't think of any other examples. It has a single inheritance model where types can or classes can only inherit from a single base. Unlike languages like C++, where you can go crazy, create diamond inheritance hierarchies, and basically go insane. Why would I want to do that? Person Nelson equals new employee. I really wouldn't. I was just demonstrating that you could do this. This is an example of where you would use this behavior. So I'm going to bring this back to employee to make this code valid again. Okay. Wait, what's the point? There's no point to that. I was just demonstrating that. Okay. So inheritance is used to share functionality or to inherit from functionality. But that being said, I'm really hesitant to start throwing up the most common inheritance examples. Like most people like this example where you have, an animal type, and then you have a dog type that inherits from animals, so that you have different properties and all that stuff, and that's all cool. But the fact is that inheritance is something that I stay away from as much as possible because it does limit things in certain circumstances. Now, you really do have to be familiar and comfortable with the concept, especially when reading other people's code. And there are plenty of instances where inheritance is appropriate, but it's difficult to kind of go over them without getting into virtual members. Now, virtual members are a way to actually provide different functionality for a base type or for a child type that the base type might have. And we're going to be getting into that next. But for right now, are there any instance or any more questions about, no, I'm not going to create an actor class. Horrible, horrible. The print person method takes in a person type, but if you pass in Nelson, which is an employee type, it still works. Yep. That's one of the things about inheritance. You get implicit conversion to the base types, meaning that an employee can be treated as a person at any point. Can you inherit data from an existing person into an employee? Not by default, no. That being said, we could write a little method here called public void copy that takes in a person. And we can say first name equals person.first name, last name equals person.last name. And then inside of main, we can say Nelson equals new employee. And then we can say Nelson.copy P1. What I've effectively done is taken advantage of the implicit casting here, where I can pass in the person into the copy method, and it's just going to copy into the two properties that we have inherited from these two properties on the person. So as a result, if I were to run this, you'll notice that we get two RDs. So you can't really inherit data. Remember this very important thing about classes. Classes are a compile time construct. Although there is such a thing in C# as reflection, or .NET in particular, classes are primarily just compile time constructs that allow you to construct objects, which are runtime constructs. As a result, there's no way to inherit data because data is a runtime concept. You can't really do that in the context of a class. You can inherit parts of the template. You can inherit the fact that person has a first name and a last name and a copy method. And you can bring that into any other type that you wish by using inheritance. But there's no way to implicitly inherit data because that doesn't make any sense. Okay, let's see. Can an employee be inherited, say, to a janitor class? Oh, certainly. That being said, this is not good design, but you can do this. That being said, like I said, this isn't good design. In fact, we're going to be spending a lot of time not using inheritance to solve problems that were typically used, that people used inheritance to solve. And I'll be going over the reasons why inheritance isn't such a good idea when you start getting really, really in-depth hierarchies. So Nelson is both types. No, Nelson is really just an employee, but he can be treated like a person. He can fill the role of a person whenever we need him to, although he still is an employee at all times. So for example, ready to blow your guys' mind? Ready for this? Ready for this, guys? The GetType method is available on every object that exists in .NET. And what it does is it returns a type object. The type object allows us to get the name of the type that this object is. So watch what happens when I run this. You'll see console application 1.person followed by rainbow dash, which, as you see, is the first person that we instantiated and printed. But then you'll see console application 1.employee is rainbow dash again because I did the copy. But the thing is that this is actually a different type. This object, the type of the variable is person, but the type of the object is an employee. And that's kind of one of the fundamental things about polymorphism, which we are definitely getting into.
Just while you're there, GetType, does that how does it differ from like using typeof?
Well, see, watch this. If I did typeof right here, actually typeof can't accept those. If I were to do typeof person.fullname, that would always print out person. But because typeof is a compile time construct, typeof only works in compile time contexts. GetType gets the type of the object, not the type of the variable. Because the type of the variable is person. The type of the object, in the case of line 41, is employee. The only way to get this information is during runtime, because at runtime, we don't know, or at compile time, sorry, we don't know if person is really a person, or is an employee, or is a janitor, or is any other derivative of the person object or person type. So this is an example of a polymorphic method, a method that returns different results depending on what type the actual, real, true, bare metal object is. If you created a class CEO and inherited from employee, would the base class still be considered person? The base class, if I did this, if I said CEO is an employee and an employee is a person and a person is, well, just an object. CEO, the base type for CEO is employee, but the base type of employee is of person. You can inherit as many levels deep as you want to. Can user reserved method name, can my user reserved method names, because the namespace, I don't follow, Eli. What if I declare another first name property in the employee class? Good question. You get what's called hiding. I will actually I don't want, because I just came up with an awesome way to explain hiding, but it goes hand in hand with override new, so I don't want to talk about it before we get into virtual members.
Could you give a quick example of now that you've got these three layers of just why it can be bad? I can't think of one off the top of my head.
Well, why it could be bad is because conceptually, what are we doing here? A CEO, an employee, and a person, or more specifically, an employee and a CEO, are pretty much very similar concepts. They're still people. The difference between those two are quite possibly the behaviors and the data on them, and maybe what they're allowed to do. Doing it this way really locks you down because you cannot share that behavior between that and other types. Like, for example, let's say we had an employee, and let's say we had a manager, which inherited from employee, and then we had a CEO, which inherited from manager, and maybe we had another class called accountant, which inherits from employee. Now, here's the thing. What if your CEO was an accountant? What if your manager was an accountant? I mean,
where do you put the accounts manager?
Yeah, and so, how could you, I mean, you can't do multiple inheritance. So you basically, once you put functionality into these, they cannot be moved around. So instead what you do is you use composition, where you create properties on a single object that can change. that contain other objects that perform functionality. So like, for example, you might have an object on the employee class called a salary calculator. And so instead of creating a new derivative of the employee class and changing that property statically, you could simply say var CEO equals new employee, and I can say CEO dot salary calculator equals new, new lots of money calculator. And then I can create another, I can say accountant equals new employee, and I can say accountant dot salary calculator equals new sum money calculator. But the point is by doing this with composition instead of inheritance, we can now reuse the different salary calculators for a variety of different objects instead of being locked down. But anyway, that was sort of digressing a little bit. But yeah, this is an example of inheritance hierarchies that just simply get out of control. And they do. They really do. Okay. Nelson can be used as a person or employee, but not as a janitor, right? Yes. I could be used as a person or an employee, but I couldn't be used as a accountant, manager, or CEO. But the print person would not be able to access the yearly income, correct? There's no way for us to access the yearly income. Can you set GetType as a method of person? You can, but it would hide the GetType member. You do not want to touch the GetType method. This should always return the correct result. And if you hide it in some way and use the new keyword, then you are opening yourself up to a variety of issues that you will, that will absolutely insanely just devastate you.
It's like doing define true false.
Yeah, pretty much. So you can't override reserved methods, and no. Well, you can't. You can hide them, but you can't override them. And there's a very important distinction. Oh, sorry, dog. Okay, so any questions so far about inheritance? Any more questions? Because I don't want to, because you go to any other book or whatever, and they'll sit there and throw a bunch of awesome examples using inheritance, and people are like, oh, that makes much more sense. But all those examples that I can think of would be better suited for other features that we're going to be talking about very shortly here.
You're just itching to use the I word.
Yes. Iron Soul, are you being sarcastic or... Okay. Because I was about to re-answer it.
That's probably a safe assumption by now, I'd guess.
No, C# cannot do multiple inheritance. At all.
Okay, my graphics card's going, so
you're about the blue screen.
Yep.
Is there anything you want to add about inheritance, Jason? Just because I know that I have such a sour
No, not really.
taste
It just requires proper planning when you're going to take advantage of it. It does have its place. It's not like it's a stupid feature and oh good heavens. It's
Oh no, not at all. And it's just this example right here isn't a good example of inheritance in my opinion. But I totally agree.
Totally agree.
There are some cases that you'd want to use it.
Absolutely.
Okay.
Also, you can do multiple inheritance. You can only inherit from one class, though. It depends on who you talk to. I mean, I've talked with Microsoft engineers that'll say, of course C# can do multiple inheritance. You can inherit from one class and 15 interfaces.
Yeah, but I think that's not inheritance, that's implementation.
No, it's forcing implementation. It's forcing a contract.
But when you don't inherit an interface, you implement. The verb is different.
Yes, you're left to implement it. But again, you can find Microsoft in their own books, and again, with talking with their own engineers, will say it's still a form of inheritance.
Well, I think they're silly, and they're probably C++ people. Because in C++, you can actually mimic interfaces by using multiple inheritance.
But you cannot do, yes, correct. You cannot do multiple inheritance with multiple classes or from multiple classes in C#. But on your inheritance line, in the definition of the class, using inheritance, you can also force a class to implement from multiple interfaces, which will guarantee that implemented functionality will exist on a given class. But we'll be talking about that in a minute.
Might be jumping the gun, but can a class do both inheritance and interfaces together? Yes, I can. Okay. So now let's talk about virtual members. So actually, why doesn't everybody just type this out right now?
Yeah, use that system, Nelson. Use it!
Yeah. All right, type it out, guys. I just reset your ready check because we're going to be working on improving this design a little bit with virtual members here in a moment, but I kind of would like a baseline for people just to type this out first. Okay.
Man, if we could interact like with our students through like a form of, yeah, this is horrible. Like we really wanted to punish people that weren't fast enough. Imagine you have to put this this old metal bracelet on and connect it to your USB and then connect it to the wall. And then
we'll get samples of their DNA to make sure that they're always connected.
And it's basically going to verify that you're truly connected. And so then we can hit we can control voltage shocks. Just light shocks if you're just to kind of get you to hurry up a little bit. Just an idea. Wick, I am not. It's just an idea. Come on. Oh, Jen, have some fun. See, Jamie's got it. Wake up. Psst, I'm awake. Ooh, that's a good point too. If it could measure your heart rate, you could see who's starting to doze off. That would be awesome. Intense classes. Yeah, adjust your font size a little bit, Nelson, or go full screen to help people that are already down to the bottom part. Oh, James, I know you're not afraid, man. Hope I'm not drinking anything when you hit the button. Here's one for you, Jamie. I hope I'm not drinking when I hit the button. Oh, dear heavens, Jason, let go of the button. You've been holding it for 10 minutes now. Ah, I'm sorry. I'm going to go ahead and hit pause for just a moment. Oh, actually, before I hit pause, if you want to answer Eli's question over on the panel real quick.
So, can you distinguish why you use right line rather than right, like you were in the last class? Right line automatically inserts a new line character at the end of the output. Right does not. So I'll often use right for prompts, like if I want some text to appear before I expect the user to insert some text, then I would use right so that it doesn't insert a new line. But generally for output, I'll be using right line.
Jen's right. Drinking would probably result in more frequent button use and laughing. Sorry, that's just too funny. All right, I'm going to go ahead and pause for just a minute. All right, the video's been resumed. At this point, I've got to assume that those of you that are still set to not ready are simply AFK. Okay, Nelson, back to you.
Alrighty, why isn't print person part of the person class? We're about to make it so, because I just wanted people to get this typed out, to get kind of used to typing out this sort of inheritance stuff, but I'm very shortly going to have people type out some more stuff, which should go a lot faster now that you have the basic program already typed out. So the first thing I want you to do is delete lines 37 through 41. And then, of course, lines 26 and 31. Okay, so what we're going to do is we're going to introduce the concept of virtual members. So let's go ahead and write public void display, a basic member on our person class, where we can say first name, comma, last name, and then say first name, comma, last name. Basically, I just removed the static display person method and the two invocations of that. Okay, so now that we've moved up the display method into the person class, now we can add a few lines of code by saying p1.display and then Nelson.display. So let's go ahead and hit F5, and you should see this. So go ahead and type out those modifications really quickly. There, I only added a single. I removed a method, added a method, and removed 2 lines and added 2 lines.
And yeah, make sure to keep an eye over on the questions panel too.
Okay, can we use var instead of person and employee? Are we going to demonstrate something with them? Yes, you can use implicit typing here, although I believe I moved implicit typing.
Wow, we introduced implicit typing already.
No, week 4? That's not right. I'm going to move implicit typing up to week 2, because then I figured after we review implicit typing that I'm allowed to use it exclusively.
Gotcha. Okay. Yeah, that's completely fair.
Okay. So say 1 minute or ready, if you guys are ready to go ahead and move on and talk about. I am trying to find a balance between having people type along and pausing and stuff. So I did have a little bit of code that I added, and then I'm going to have a little bit of code that we add again here pretty soon that I want people to type out as well. It's kind of hard to get that kind of balancing act working between waiting long periods.
I do agree with Wick though, and that's take the comma out. It looks like the names are backwards, but they're not. How did I know you were going to do that? Well, all right, that's acceptable.
Okay, so moving on. So right now, if we go ahead and run this, then you notice that we get the same output on both ones, and that's not very interesting. What we want is we want our employee class to behave differently than our person class. So let's go ahead and do what comes to mind first. Let's go ahead and add a display method to our employee class. And let's say that we're going to print out the first name, the last name, and the salary. Okay, so again, click ready or 1 minute. You will get a compiler warning. However, the code will still work as expected, but we're going to run into some very interesting behaviors here very shortly.
While people are typing, just in case there is anyone who's come in late, buzznet.3dbuzz.com is where you will find Buzznet. Oh, you know what's happened? All the questions I deleted from my questions panel have reappeared.
Huh.
I just answered a question from like the beginning of class.
I was wondering. I was like, where did you get that question from? He has his reasons. Okay. So we have a few people still typing out. And one more person still typing out.
There's a question in the questions panel.
I think I answered all those.
It just
Unless
appeared.
Really? Because I didn't see one. Oh, I get a message that new is required. Yes, that is the warning I was referring to. It's actually not required. You should be getting a nice little compiler warning saying that the new keyword should be used, which it should be. And all the new keyword's going to do is get rid of that warning for you. It's not going to actually do anything differently.
But why is it there?
Well, we'll see.
Oh, okay.
Okay. So right now the program behaves just like it did before. You'll notice we have two classes that inherit from each, or one inherits from the other one, and we'll both have this display method on it. So this is really cool. We can redefine functionality on a per class basis. I mean, it's really great that we can do that because it allows us to do a variety of interesting solutions. But wait a sec, what? Okay, guess what I did? We have an employee.
What?
We have an employee Nelson equals new Nelson, or employee Nelson equals new employee, which is nice, which is what we want. But if we were to have done this, which remember, this is valid. This is perfectly valid code because Nelson, an employee, is a person. So Nelson is a person. And so we can implicitly cast employees to people. But watch what happens. Does anybody kind of see what's going on right now? Or okay, watch this. If I change this type to employee, fire up my debugger and hit F11, 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 notice it jumps down to line 25. Okay? Now, if I were to change this to person and hit F11, 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 now watch what happens when I hit F11 again. We jump up to line 15. So that's really not what we want because we're not getting polymorphism here. We're just getting a static invocation of a particular class member. Although employee is a person, when we use a employee as a person, right now we are just getting this behavior still. There's no way for us to override this behavior. So for example, let's say I have a method. In fact, let's do one even better. Let's say I have a list of people. Can anybody guess the output of this program?
Polymorphism just means many shapeism.
Yes. Polymorphism is a concept that is incredibly, ridiculously, stupidly important for doing object-oriented designs. And what it means is that one type, the type of the variable does not indicate the type of the object. So for example, we have a list of persons, but called people, but the objects we can stuff in this list can be anything that inherits from person. So as a result, we can have many, many diverse types of people inside of this people list, but they're all persons ultimately. Polymorphism is the idea that you can have two similar looking variables, two similarly looking objects that actually perform very different things. It means they have many forms. Okay, so what do we have? Really, not many people actually answered that question. Oh, we did get...
It did sound rhetorical.
It wasn't rhetorical. I do this all the time. What's the output of this program? Come on. You guys have compilers in your heads, don't you?
Yes. But then I'm a freak.
Okay, so I'm going to go ahead and hit F5, and we see we have Dash, Rainbow, and LaK Nelson. That's because it's invoking the person display, not the employee display. And the reason it's doing that is because we are doing what's called hiding. This method hides this method, which means if we invoke the display method on an object that is typed to employee, we get display. If we invoke display, or this display in particular, if we invoke display on a variable that, or an object that is typed to person, we will always get this method. So the C# compiler realizes that you probably don't want this behavior. So as a result, we get this warning saying it hides inherited member. Use the new keyword if hiding was intended. So there's actually a keyword called new that's not like the new operator, but basically says, okay, C# compiler, I know what I'm doing, shut up. That's all it does. But it still is very intended behavior.
Because it's saying to you, hey, look, this could get really confusing really quickly.
Yeah, it's saying that there's no reason for you to be doing this. This is stupid. Why? What's wrong with you? And then you can use the new keyword to say, hey, C# compiler, I know I'm stupid, just leave me alone.
But what if you want to say, all right then, do it your way?
Well, the proper way to do this, or the way that we get our intended behavior, and WIC actually does bring up something important.
Also, after you mention that, don't get too far away from display yet until you answer the question over in the questions panel.
Which one? What if person had no display?
Yeah.
Well, if person had no display method, but employee did, we'll get a nice little compiler error here on line 43, because this variable, this object, is typed to person, so it must have a display member, or it has to have one if we are to invoke it.
Person, because it's inside that loop, it's a person, not an employee. It's a person, and a person doesn't have a display method in that situation, so it can't. Because it doesn't know. This is the thing. There could be something else, management that isn't an employee but is a person. That it has no way of telling then whether it's an employee or a person. And thus knowing that it should be looking for a method. As far as it's concerned, it's a person, and person doesn't have a display method.
Well, see, here's the thing about, I guess, got a question. What happens if you instead use the employee's display? Here's the thing. This is a situation that I came up with to demonstrate why polymorphism is important, because this is a very common situation where you will have a list of an interface or a list of a base class, and you want people to be able to add items to that list that are custom classes that inherit or implement from the base. So this is a very common scenario. Well, you will have a list of things, but you won't necessarily know what type those things are. So we need this list of persons in order to be able to add both person and employee to this list. But because this list is of type person, when I loop over it, I can only use the person type here as my iterator, as my item variable. And because I can only use the person type as my item variable, I can only invoke the person display method. I cannot invoke the employee display person, or I cannot invoke the employee display method.
Okay, if you can answer this with yes or no, do so. If not, don't worry. But if you were to use LINQ where person goes to is of type employee, could you then use employee.display or not?
Yes, you would use the OfType LINQ method. That basically is just what you explained. It's actually, yeah, but still. Yes, the answer is yes. Okay, can you use GetType.display method as you iterate through the for each loop? No, you can't. Well, I mean, you kind of can. You can say GetType, get method.
Let's try not to get too far away. Yes, let's not get too far away.
But you can.
We will get complaints.
You wouldn't want to do that. You really wouldn't want to do that. Can you run it again? Yeah. Notice how we get the person display. We don't get the employee display. We get the person display, even though Nelson LeKay is an employee. He's not just a person. He's also an employee. So right now, this method is only getting invoked right here. There's no way for us to alter the behavior of this method inside of our base or our child types because they're just hiding the member. They're not actually redefining it. Okay, so any more questions before we get into virtual members?
All right. Wait, nope, question.
There's no problem with the list type person holding a variable from the employee class? No, none at all. Perfectly valid, perfectly legal, very commonly used. Solves a lot of problems.
Yep.
Okay, so moving on, the way to actually get the expected output is to use what are called virtual members. A virtual member is a member that can be overridden in child classes, and that is basically the backbone of polymorphism. So remember, right now we're using hiding, but to use a virtual member, we could do this. Not surprisingly, we add the virtual modifier to the base class method. But right here, we'll get the same sort of thing. We'll say it still hides that member. So we actually have to add another modifier to this method in order to get this to work. So if I hit F5, we'll get the same bogus output, even though I did add this virtual keyword. But now what we can do is add the override keyword right here. And now when I hit F5, we get the proper output. And just to make it even more clear, I can say person dash and then employee dash. So we get person dash
Dash.
Wow. Person dash dash rainbow and employee dash Nelson LeKay 10.
Yeah, it's not confusing at all.
You're planning getting married to her, aren't you?
One of these days.
Oh, God.
I've heard of weirder things, but still. Okay, so.
It's psych fault.
Oh.
Continue.
Okay, so okay. As of right now, we do get the proper result. We get the result that we expect because we've essentially defined the person template, and we've overridden or we've created a new template called employee that we've based on the person. But we want to have distinct functionality between both of them. That's very, very, very important to object-oriented programming. Okay, so Iron Soul, yeah, remove new and add override. Okay.
In fact, if you put the override, if you take out the virtual, where the override is, it'll tell you.
Yeah, it'll.
Won't it?
No, it'll freak out on this one. It'll say, cannot override inherited member because it's not marked as virtual, abstract, or override.
Oh, it's a resharper thing. Resharper tells you, and obviously fixes it for you. But
okay, so how do people feel about virtual members so far? Fun. Let's do something fun with virtual members. Let's go ahead and let's go ahead and write a function, a method actually, that returns a person. Let's say get person from input. And what we're going to do is we're going to say console write line, console write line, and then we're going to say 0 for a person, and then 1 for an employee. And then we're going to say int choice equals int.parse console read line. We're going to say if choice is 0. Actually, that's terrible. I'm in 0 index mode right now. If choice is 1, then let's say, okay, let's create a person and do person.firstname equals console read line. Actually, I'm going to create a static string prompt or get string prompt.
Salary. I've got to say, or years down the line, we'll be getting PMs, like the whole amount thing.
Alrighty, so now we can go ahead and say, we can say for int I equals 0, I smaller than 5, I plus plus, and then we can say people.add get person from input, and then we can say for each person in people person.display. So what we have here is an example of polymorphism where the user can select. What?
Never mind.
The user can select what kind of person he wants to create. And you'll notice that that works just like expected. So we were able to write code here, real life code right here that actually works between two different objects that the user can select. We've effectively reduced a lot of code that we would normally have to write to get this exact behavior.
Iron Saucers, what we have here is something I haven't copied down yet.
Are virtual members only for methods, or you can set a variable as virtual and then change the getter, setter. Methods and properties can be virtual. For virtual, you can override, but you don't have to. You do not have to override a virtual member, no. Can employee.display inherit from person.display so that you only have to add the salary to it? Yeah, I'm going to go over a bit of syntax in a moment here that'll show a similar thing. Okay, so this is an example of us allowing the user to select two distinct things. So right here, this code right here has the knowledge of what a person is and what an employee is. So we have code that does know the difference between the two, which we have to at some point. At some level, we need to understand the difference between the two types. But at this level, we don't. At this level, we can add as many objects that inherit from person into our people list, and we can act on them in any way that we want. But the behavior, what actually happens right here, what method gets invoked right here, is up to what the user decided to put into the array, or sorry, into the collection when he was inserting all the users. Is there a way to force the parents class method to execute instead of the inheriting classes? No. Well, not without reflection anyway. But there's no way to get to force that the person's method is going to be invoked here. If the employee decides to override it, then this is the method that's going to be used, period. You can with reflection, but we're not getting into reflection. Okay, so are there any people who are feeling uneasy about this code and about what we're doing here with people? Feel uneasy about what we're doing with people? Sounds horrible.
At least it wasn't ponies.
That's true.
Java, which bit do you not sort of get?
How tricky would this code be without using virtual? Yeah, have fun with that. Okay, so now I'm scrolling to the top again. Someone asked. Well, actually, let me throw in something also that's interesting. Remember how I said calculating salary might be something? So let's say we have a public virtual int calculate yearly income, and we have an int year that's passed in. And then we can say in our person, we can say if the year is smaller than 2,000, then I made...
Wouldn't that be better on the employee?
That's fine.
I'll take that as a yes then.
Yeah, this isn't a perfect example. I mean, I just want to put some sort of algorithm right here that we can use to determine some sort of result based off the parameters. So here is our calculate yearly income method on our person. So now if we go ahead and say person.display, then we can say console.writeLine yearly income for year 2004. And then we can say person.calculate yearly income for 2004. So now you'll see that if I go ahead and hit a 5, oh great, this is going to be fun. I don't have a constructor.
Be very careful here, Nelson, that you don't end up confusing a bunch of people. Lots of jumping around real quick. Hey, Streeter. Oh, you've already killed NATO. He's confused.
I think that's NATO's default state. Like for the C listeners.
Yeah, once you get done typing this, but make sure you go back over it because there's some people that's confused.
Okay, so what I've done here, is I've added a member here to our person type, And I've said public virtual int calculate yearly income for this person given a particular year. And inside of this, I put this really interesting algorithm that performs a lot of interesting calculations that are applicable only to people.
Yeah, that is interesting.
Yeah, it's a very complex algorithm. It took me years to develop.
Lots of zeros, too.
Writing actually an academic paper on it now. And we have this algorithm in here that calculates the yearly income given a particular year for a person. And so now jumping back down, I've added a person and an employee to the people list. So if I go ahead and hit F5 now, we'll get person Nelson LeKay, yearly income for year 2004, 10,000. Employee, hey whoa, 23, yearly income for year 2004, 10,000. But that's not necessarily something we want. We want to actually alter the behavior of this program depending on if the object we're asking to calculate the yearly income is a person or an employee. So let's go ahead and do that. We can do that by using an override. We can override the calculate yearly income method. And now I can say, well, it doesn't matter what year I'm at. I'm going to make 1, 2, so that's 10,000 million, $10 billion. Oh, great. Integer overflow.
Int.
Dope. Okay, so now I've overridden the code in my employee type. So now when I run this program, you'll notice that my behavior's changed. This sort of coding is very, very important and the concept of polymorphic types is incredibly important, something we are going to be using very, very, very much throughout the rest of the course. So if you don't instantly see what's going on here, then that's okay, as long as you have a good sort of idea about what we're doing. But we're going to see ways to apply this in a variety of very interesting and useful ways later in this class. Okay, are there any more questions?
Guys, we're going to be taking a break in a minute.
Do you want to scroll up to the very top? Just for something to do.
And make sure you look over in BuzzNet too, though, guys. Please keep in mind for Nelson to get feedback, please put it in the question panel. He'll see that for sure. There are no for sure's with BuzzNet chat.
I tried to discourage Nelson from leaving looking at BuzzNet.
Was the example with calculate yearly income just a rehash of the example with display? Yes, except for it's a little bit cooler because it's a pure method that it's a bit of logic, a bit of really important calculations.
Still say it'd be better on an employee. Because the person hasn't got income.
They live in like a state that has lots of social
Tax, no tax accounting required.
And another question came in for you.
I don't. Oh yeah, well, Barry. Yeah, I'm going to get into that. There are a few things that we need to talk about with inheritance. We need to talk about constructors, and we're going to be talking about the base keyword. And the base keyword is going to be what we're going to be using to invoke functionality from the base type.
Surprised you haven't pulled out a whiteboard, Nelson, to help with, the concepts of inheritance and all.
I think
For someone who's...
I really want to get away from...
You want to get away from what? Whiteboarding?
Inheritance and talk about interfaces pretty soon.
Well, that would be ideal for talking about. If you just were to whiteboard this what you've got here or similar out with a few levels of hierarchy inheriting, and then show how you go about doing it with composition instead.
Yeah, I mean, I can
I mean,
draw something really quickly, and before we go on break, so they have something to look at, or something to laugh at.
yeah, if you want to. I mean, if everybody's completely following along and there's no problem whatsoever, then no, you don't have to. I mean, I'm not seeing questions come flooding in, so I guess everybody's completely getting it.
One of these days, NATO. One of these days.
Okay, well, we're right at the 2-hour recorded mark. Let's go ahead and take a break. 10-minute break, and then we'll come back and we'll get on to the next part, okay? So let's do that. We'll see you guys in 10 minutes. Okay, and we're back.
Alrighty. Okay. So we did get some questions. People are asking a lot about base stuff. So that's definitely something I'm about to get into.
Yeah, that's coming up.
So if we had a third display method that inherited a third inherited class, the keyword override would be used again, or should we use virtual override in the second class? Yes, override would be used again. So if I said class stuff is person, I could say public override display again if I wanted to. Okay, so what we can do here is let's go ahead and talk about the behavior of constructors as it relates to inheritance, because this becomes incredibly important and something that a lot of people get confused about. So let's go ahead and talk about constructors. I'm going to add a constructor to the person type, and it's going to take in a string first name and a string last name, and it's going to set first name to first name and last name to last name. Now, we will get some compiler errors, however. The obvious ones is that we get compiler errors down here, so we have to change this to Nelson LINQ, just like we did. I mean, that should be pretty straightforward at this point, because this now doesn't have a default constructor. The only constructor it has is the one that takes in 2 string parameters, which we have to specify. We have to do the same thing down here, so I'm going to do that right here by saying get string first name, comma, get string last name. So now those compiler errors go away. But I still get a compiler error. And the compiler error that I'm getting is that employee doesn't have a constructor that invokes the base constructor. Now, here's an important thing about inheritance. Inheritance does not inherit constructors. I could have 50 billion constructors on my person class, but none of them would be inherited into employee. So what we have to do is we have to create a constructor on an employee that in some way invokes a valid constructor on person. Now you'll notice the error we get is a little funky looking. It says console application 1.person does not contain a constructor that takes 0 arguments. What's happening here is that the default, because we have not specified a constructor on employee, the default constructor on employee that the C# compiler generates for us takes in no parameters. And it's trying to invoke the constructor on the parent class, because that's how constructors work in inheritance. You have to invoke the constructor on the class above this. You have to invoke the constructor on the class that's a base of the child. So you always have to invoke the constructor on every type that's in the hierarchy. And because we don't specify a constructor here, it's trying to invoke a default constructor on person, but person doesn't have a parameterless constructor. So we need a way to specify a constructor in employee that delegates back into person. And we can do that fairly easily. We can say public employee, string first name, string last name, and then int yearly income. We can say yearly income equals yearly income, but we'll still have a problem. If I build this, we still get person does not contain a constructor that takes 0 arguments. We have to add one more bit of code. Here's that one more bit of code. By adding a colon, the word base, and then invoking the constructor, we have satisfied that the fact that we have to invoke this constructor on this class in order to instantiate it. So now we have a few more errors. The errors that we're getting now are from employees. We just have to do the same treatment we did before. So same thing right there, and then the same thing right here.
It's worth noting that call to base is between the parentheses and the curly braces that indicate the method body.
Yeah.
And Nado's saying he's very confused now.
Okay, so now if we build, we get successful build. Okay, what we have done is we created a constructor on this person type, meaning we have to invoke this constructor every time that a person is instantiated. I mean, do you follow so far, Nato? Because we've declared this constructor, we have to invoke this constructor every time we instantiate a person. Okay, now because an employee is a person or inherits from a person, what we need to do is we need to invoke that constructor right here, but we're invoking a constructor inside of a constructor. We're actually invoking the person constructor by saying colon base and then passing in a list of arguments. So you'll notice I'm threading these parameters through. I'm saying first name, last name, and yearly income. Then I'm threading first name and last name into the constructor of the base type. And remember, constructors are not inherited. Constructors only exist on the types they're declared in. Therefore, when we have a constructor that requires parameters and there is no parameterless constructor, we are forced to, during construction, invoke the base constructor of the type.
Conceptually, it's very much like doing the first thing you do in the employees constructor being a call to the constructor of the, like any other method call.
Yeah,
you've got colon base and then the parameters that are required by the base, which is the parameters that are required by the constructor, being the two strings. I'm not saying that real. The person's constructor doesn't care about the yearly income.
Right, and we could have just as easily not taken these in as parameters for the employee, and we could have just passed in constants. We could have just done this if we wanted to. Still works, but we want to thread in the values, so that's what we're doing here.
Curry J, does that answer what you just put in BuzzNet? Or not?
I guess I don't understand why you have to have the parameters in the employee constructor. Because this constructor does not exist. It only exists in the context of person. So we have to create a constructor, or we don't have to, but we are creating a constructor that's going to delegate part of its construction process back to the base class.
It's almost as if it's sort of subcontracting it.
Yeah. We're invoking some base functionality here. So then when we do this, when we instantiate a new employee, we invoke the employee constructor. And then the employee constructor turns around, takes these strings that we passed in for first name and last name, and hands them off to the person constructor. So if we actually step into the debugger here, if I hit F11, you'll notice we jump first into this line right here, line 39. But then if I hit F11 one more time, we jump all the way up to the person constructor. And then after that, we finish the employee constructor. So for example, if I went ahead and added some console write lines and said console write line in person CTOR, and then up here on employee, I said console write line in employee CTOR, and ran this, you'll notice that it says, well, hold on, let me get rid of this instantiation real fast so that doesn't collide. You'll notice that we get in-person CTOR and then in-employee CTOR.
So NATO actually, it scrolled off. Hang on a sec. He said he put. So the base variable. Oh no, that's not it. Where was it? So something about it creates. Oh, so does it technically create a person, then alter it to an employee and add the extra member?
Not really. You could think of it like that conceptually, but an employee has all of the inherited members from person. So an employee has a first name and a last name. Well, how about this? Let's go ahead and I'm going to add a public void do stuff method here. And do stuff method is going to simply say stuff has been done. Okay? Everybody good with this method?
It's efficient.
Yeah. So now so now I'm going to say employee1.doStuff. And when I hit F11, we're going to jump into the person class. But remember, we aren't a person, we're an employee. But because the employee type inherits all of these members, we get all that functionality. Okay, so we don't have to call base and just assign first name and last name and employee CTOR. No, we can do whatever we want here. We could say ASDF if I wanted to. And then if we run this thing, you'll see there's an ASDF employee. Does it make two data types for the same person, one employee type and one person type? Nope. It creates one type of type employee that just happens to have, imagine that the C# compiler copied and pasted all of the functionality from person into employee. So we are using the parents constructor by using base. Yes, this invokes the parent constructor. Can you show the code for the getInt method? Yeah, it's very similar to getString, except for it returns an int. Dave, if you took out the base keyword altogether, you get a compiler error.
I just want to double check. This is the reason we have to do that. It all comes down to the fact that we have a constructor that takes parameters.
Yes.
Yes. In the base.
If I didn't have this constructor, then you'll notice that down here, this becomes an error. I can still do this, actually, if I wanted to. This still works, but it's actually not required. I could have simply have done this. But because the parent class has a constructor and only one constructor, and that constructor takes in parameters that must be filled upon instantiation, because of those things, we have to use the base keyword here on all of the constructors we add to the employee type. Okay. If you have an array of persons and you have one as an employee, how is the memory arranged. The memory is arranged. Remember the difference between null and a thing that exists? Remember how we have to instantiate things? Like you notice I say person P1 equals new person, employee E1 equals new employee. Do you want me to blow everybody's mind right now? You guys ready? The data allocated for both of these variables is the exact same. In a 32-bit process, the data allocated for those variables is going to be, did I say 32 or 64?
32.
32.
Okay, in a 32-bit operating system, the data allocated for these variables is going to be 32 bits wide. In a 64-bit operating system, the data allocated for these variables is going to be 64 bits wide. That's it. What's happening here, these are actually references. The types, the actual data that contains person employee are instantiated and acquired from this heap. So you can store these side by side, these references side by side, or these objects side by side in lists and arrays and all that stuff, because they're the same bits wide.
Yeah, I think because initially you said these are the exact same, and that really confused me. They're not. They're different memory.
Yeah. Well, what I mean is the memory allocated for this.
They're the
variable.
same. The size. They're not the same.
Oh yeah. They're same in size, but they're the same. They're just references, and references in C# are a reference is a reference is a reference. They're all either going to be 4 bytes or 8 bytes, depending on how many. So you what?
No, carry on.
Huh?
Carry on.
So lists are stored in heaps and not stacks. No, lists are stored on the stack or on the heap, because the reason we know that is a list is a class, and all classes are going to be stored on the heap. And you what?
Yes.
Hello.
Hello?
Sorry, I'm.
Gavin, Gavin, you might want to just go ahead and leave it paused. I mean, mute it, because you seem to be falling further and further out of sync, and it's making things a little confusing. Okay, Nelson, continue.
Okay, so that's why we can store these side by side in this list, because these are just references. The actual data, the actual memory that holds the fields inside of the person and employee types are stored on the heap and allocated when we apply the new operator. Okay. For the employee, can you use default values? I'm not sure what you mean by that. I mean, as you see right here, we can pass in these defaults into the base constructor. We're not forced to thread parameters into the base constructors. Oh, we haven't talked about parameter defaults yet. I don't think.
No, we have not.
I hope not. Yeah, because those get interesting. So the base constructor is always executed first. Yes. The parent most types constructor is always executed first. So what happens when we have two parent constructors? The rules of method overloading still apply. For example, if I had a public person that just took in a string name and set the first name to the name variable, so I added another constructor overload here, the way we distinguish between this constructor and this constructor follows the exact same rules as method overloads. So down here on the base, you'll notice if I hit Control-Shift-Space, IntelliSense pops up and informs me there are two overloads of this constructor that I can choose from, either by providing two strings or a single string. Okay. All right. So, are there any more questions about this? Is anybody still kind of confused a little bit about the base constructors?
Please speak up
I know we're
if you
moving.
don't. You know, yeah, we'll take all night if we have to. I don't care. Please make sure that, you know, if you're a bit confused about it, don't worry. For those that end up having to go to bed, because I know it's really late for some of you guys, you can always go back and watch the video later. But I'm not wanting to put those of you that are completely confused in a situation where I say, go and watch the video and that's going to make it clear for you, because that's not true. That's why we're here. I would be much more interested in you guys saying, look, I don't get it. And for those that are watching this right now that do get it and it's getting late, they can always watch this video when it gets put up. You guys all have credit for showing up for class today, which is great. But I am more interested in the education. So for those of you that, if you're having trouble with this, if there's something that you can put your finger on saying, I don't get this, please don't be shy and let us know so that we can try to help make sure you understand it. If you guys all play by that attitude, those rules, we'll make every single one of you guys awesome programmers.
Nelson, did you see Wick's comment in BuzzNet go past?
I did. Wick says, I guess I'm wondering, constructing these worked without defining all this base stuff. Why use it if it works without? It's the same reason why you would want to use a constructor. A constructor, if we didn't have constructors like what we had before, remember, this worked. This was fine. But because I wanted a constructor, this is what I had to do to make it work with inheritance. And the reason I wanted a constructor, it really depends on your situation. But at a very conceptual level, a constructor needs to take in all the data that's required in order for an object to be considered to be in a valid state. So you always want your objects in a valid state, and a constructor is an opportunity for you to constrain the ability for somebody to create an object without providing data that that object needs to behave or needs to work with.
By creating that person first name last name constructor, it's forcing that, you know, there's no way for somebody to create a person without giving them a name. That means that if then you'll go ahead and store that in a people list or do anything with it, you know that it's going to have at the very least a first name and a last name. It very nearly it's sort of the definition of what makes it a person.
Right. Yeah, it's you're enforcing the invariant. What happens if you overload a constructor in the base class and child class? You can't overload constructors. Or wait a sec. You can't override constructors. You can overload constructors, yes. If you overload a constructor in both the base class and the child class, so if I were to introduce another overload here, and then another overload here, I can choose which one of the base constructors I want to invoke. I can invoke the one that takes in first name and last name, or I can invoke the one that takes in name. So I can choose that. Now, if I introduce a third class, now this is very important. If I introduce a third class, here's the important thing. Because constructors aren't inherited, my child class needs to have a constructor that invokes not the person constructors, but I need to create a constructor in the child type that invokes the employee constructors. So I'll only have these two constructors to choose from. So you'll notice if I go ahead and say public child and then add in the colon base, you'll notice that the only constructors I get to choose from are the employee ones. It doesn't care about the person ones. Because if I pass in first name, last name, and yearly income, what's going to happen right here? Is it's going to thread these values into the employee constructor. And then it's going to thread these values into the employee constructor. And then the employee constructor is going to thread these values into the person constructor. The program crashed if you didn't force these constructors. The program would have the potential to become an invalid state. And part of programming and part of good object-oriented design is all about reducing the possibility of your program going into an invalid state, enforcing valid state throughout the execution of your program. So no, it wouldn't crash necessarily, but it would give you more opportunities to create code that does crash your program down the line. Okay, so time to move on from constructors now that I've thoroughly confused everybody in the class.
Yeah.
Yeah, we can move forward, and
I'm not seeing any more
right,
questions.
and as people have questions, if new questions arise, we can simply back up.
Okay. Yeah, well, first I just want to talk about base a little bit more, because we are going to be talking about abstract classes here pretty soon. But I want to talk about base. You can use base in one other context. And somebody was asking, could I write a calculate yearly income implementation on my employee class that is written in terms of the execution of the calculate yearly income method on the person class? The answer is yes. We can use the base keyword, and we can say base dot calculate yearly income year, and then we can modify that value even more. We can say, okay, employees get 100 times the yearly income that normal people do. By adding the base modifier, we are specifying that we want to invoke the parent method. Okay, so did that, I know a lot of people were asking how we could do this. Does that answer your guys' questions? Are you guys all good now? Because we're about to move on into abstract classes. With two classes you call base and child, what's the terminology once you add a third? Honestly, the situations in which I have an inheritance hierarchy of 2 or more types is rare. But base and child are relative terms. For example, the base of child is employee. If I were to talk about child in terms of if it's the child, I would say yes, because it is the child. I mean, not literally, but I mean, it is literally, but
well, it's the grandchild of person.
ASDF is the child of employee, and it's also a child of person. And depending on the context, I might refer to different things as base or child. But generally, when I say the base class, I'm referring to the class immediately above it. Okay, so people are asking about a whiteboard. I want to bring up one more. I want to introduce one more small thing called abstract classes and abstract members, and then I'll throw up a whiteboard because I came up with a better idea, a better example that we can use to look at this stuff. So let's go ahead and talk about abstract classes. So I'm going to go ahead and nuke all this code. I'm going to keep my get and get string method though. Okay, so let's say we have a class called item, and we had another class called, I don't know, chair that inherits from item, and another class called, I don't know, potion that inherits from item, and maybe another class called gun. No, not actor. So we have 3 items. We have a chair, a potion, and a gun. Now, in our actual item type, hello?
Gun inherits from potion.
Well, why did I do that? It's a gun potion. I don't know what that means. Okay, so we want to go ahead and declare some virtual members on item. We want to say public virtual string display, for example. And, well, actually, I'm just going to make this void, and I'm going to do a console.writeLine. But here's the thing about this. Are the scopes from parents to child valid? Oh, yes, we still need to talk about protected. I don't know why that wasn't in the outline. We'll get to that. Okay, so what we have here is a public virtual void display method, and we want to use it for all our different items. So let's say that, let's go ahead and write some more code. Let's say, what's the model of our chair? I want my resharper. So then we'll have a public override display, and we'll say console.writeLine chair model. And then our potion, we might have a type. Was that directed at me, Gavin?
Chair, not char.
Oh. I'm just full of awesome typos today. Potion, type. And then we might have a gun, and we'll still have a gun type. So each one of these classes have distinct functionality, but we want to store them all in a list. So let's go ahead and do that. I'm going to create a list of items. I'm going to call it items. I'm going to say, actually, no, I'm going to call it inventory. We want to store an inventory of items. And let's say in our inventory, we have a chair. And this model is stuff. And we have a gun, I don't know, an AR-15. And we have a potion, let's call it a health potion. And then we want to loop through our inventory. And we want to display them all. So we get a chair, a gun, and a potion. And these aren't the only types of methods that we could have. We could have like a use method. For example, we could have a public virtual void use. And we do public override use, and we can say console writeLine use sat down. And then we could have another use in our potion called, I don't know, stuff happened. And then we could have another use method and just do like bang. And so let's say we want to display our items, then we want to use them. So we get a chair, we get a gun, and we get a potion. And they're all in our inventory. Okay, so is everybody at least comfortable with this? This example is using stuff that we've learned up to this point.
But you wouldn't actually have to have a use on everything, would you? As it stands.
Yep, there's actually a variety of problems with the code as it stands. There are 3 problems. First problem is I can instantiate an item. What's an item? Well, it's an item. That's it. Doesn't really do anything. In fact, the only reason I made the item type at all was so that I could or override these methods. I don't care about an item type. I don't want to be able to instantiate an item. I only want to be able to derive from it. Second problem, this implementation. Remember, methods, virtual and non-virtual methods require an implementation, but the implementation is empty. It's pointless. It's useless. I don't like it. The third problem is what Gavin pointed out, that I don't, like, let's say I wanted my potion to do nothing, and I could do that. I'm not being forced to implement any of the members inside of item. I could just leave these out if I wanted to. And that's stupid. I want somebody who inherits from my item class, I want to force them to provide functionality, because if they're not providing this functionality, then they shouldn't be inheriting my item to begin with.
Yes, don't drink a potion if you don't know what it's going to do.
Yeah. So abstract classes and abstract members solve this problem. That's sort of interfaces, but we'll get into those later. Instead of saying public virtual void display, I can say public abstract void display. Now, I'm about to receive 2 compiler errors. Bam, I called it. I get 2 compiler errors. The first one is an abstract member cannot have an implementation. An abstract member can only have a signature. It cannot have any implementation in it. So let's delete the implementation. That's problem number 1. The second problem is that an abstract method or an abstract member inside of a class, if you have one, you have to mark your class as abstract. So this must be an abstract class if I have any abstract members within it. So now I get a build succeeded. So I'm going to do the same here. I'm going to say abstract void use, Control-Shift-B, build succeeded. So now you see that everything works just like it did before. I have an abstract class item that forces people to implement display and use.
And note that when you get rid of the body, you obviously have to put in a semicolon. You're now you're just declaring the display and use methods essentially, just as if you were declaring a private string model.
Is this kind of like prototyping in C++? Not exactly. C++ actually has virtual and abstract, the virtual and abstract concept inside of it. Actually, it's called virtual and pure virtual. So Nato, what parts are confusing? Basically what I've done is I've created a class that forces every inheriting class to implement these 2 methods. So now you see down on line 78, I can instantiate a list of items named inventory, and I can add my chair, my gun, and my potion to that. And then I can loop over it and invoke these particular methods on it without knowing what kind of item it is. All I know is that every single item within this list has a display method and has a use method. And because C# is a statically typed language, we need to be able to know at compile time whether or not a piece of code should work. Yeah, like what Segfault said, but we will. Okay, so now let's go ahead and fix our problems, or let's go ahead and go over those 3 issues that I said before. First issue, can I instantiate an item anymore? Answer is no. I get an error, cannot create an instance of the abstract class. So problem 1 solved. Problem 2, is there any implementation that I don't care about that's cluttering up my program? The answer is no. Neither of these methods have an implementation. Third problem, am I forced to implement these 2 members on every type that I inherit from item? The answer is yes. You'll notice that if I remove that method and try to compile, I get a does not implement inherited abstract member console application 1.item.use. So all of those problems are resolved.
Nelson, you might want to explain what abstract actually means. NATO's really confused with that. And people are asking if you could please slow down. You're starting to leave people behind. Which is all good. Nelson just gets excited when we start getting into the better stuff like this.
Okay, so do I still need the override keyword? Yes. You'll notice on line 68 I still am forced to override.
What's abstract mean? I mean, it's abstract.
Well, Yes, abstract means that it is a member without implementation. Abstract means it's actually, it's hard to actually define what abstract means. It's easier to define what abstract does. What abstract does, by adding the abstract modifier to any member on, or except fields, of course, because that doesn't make any sense, to any property or method on a class, you are doing a few different things. You are saying, I am not going to give an implementation for this method. Any class that inherits from me must implement this method. And nobody can instantiate the class that this method is inside of. So basically, abstract does nothing. Yes, it doesn't do anything. It just forces us to do things. It forces us to do things as developers. It doesn't really do anything. In fact, it does the opposite of something. But it allows us to use polymorphism inside of a statically typed language. As you see right here, I'm instantiating a list of items, and I don't care which one of these items are. I don't care if the item is a chair, a gun, or a potion. It doesn't matter to the inventory local variable. This can contain as many different types of items that I want. And then when I loop over those items in that collection, I can invoke the display method and the use method. The reason I can invoke display and use is because they're defined up here. They're made available to us statically. What?
That's the key thing there as well, which is that because in an abstract class you have to implement the members display and use, that is the only reason that you can safely then in your for loop further down say item.display and item.use. Because if they were still virtual and potions, say, didn't have a use, how can item.use happen on the potion?
And if we didn't have these abstract members, then because we don't have the guarantee that these are being implemented, you'll notice that line 84 now becomes an error. Because this member no longer exists, the C# compiler cannot know for certain that this code is going to work. And it has nothing to latch onto. It just doesn't know that it exists. By declaring that abstract member, we're declaring its existence and forcing everything that inherits from item to provide that implementation.
Yeah, Wick said, I like that phrase code contract, and I know that's a phrase Buzz uses a lot for this sort of thing.
It is.
That wasn't a leading sentence at all. Well, I was just thinking a different way of explaining it is often as useful as further explanation, if you see what I mean.
Sorry, we're talking here?
I didn't know if Buzz had anything different to say about the subject.
No, it's just nice using contract when you want to create other classes that must for sure guarantee certain implementation, certain methods that are implemented. And so it's a way to force a contract.
Somebody points out, or somebody says, there's a lot of defensive programming going on here, and realize that the features that we're going over right now are not features that people instantly thought of when programming languages were invented. The features that we're talking about are features that were given to programming many decades after programming even was invented. And for many decades after that, they weren't even accepted as standard use. The only reason these features exist and this way of coding is encouraged is because it has been shown time and time again that once you start getting into systems with large complexity, these features make it more difficult to write incorrect code, if used properly, of course. So it is very defensive. We are enforcing a lot of things, and we are enforcing a lot of things on people who write this code and maintain it. We're also providing well, Florin, are you done copying main, by the way? I feel bad because I've been scrolling up and down so much, and I realize some people are still copying. But anyway, by saying that item, or by looking at the item class, A maintainer or a reader of this code instantly knows what to expect from your code base. Provides a very good contract.
A good attitude to take when you're writing code is that you're writing it for somebody else to use. Immediately, you then have to name methods sensibly. You have to name variables sensibly. You have to, basically, in the same way that, I mean, your getInt and getString there are perfect examples of, you need, actually, int.tryparse is the best example. You don't know what a user's going to type in. So if you're going to accept user input that you want to be an integer, you use int.tryparse so that you can guarantee that what comes back is going to be an integer, or you deal with it in another way. And this is just like that. You're guaranteeing that whoever uses your potion class, for instance, must then in their or say somebody else decides to create another item, a table class. If you go to create a table class, it will now tell you, if you inherit that from item, it will tell you, okay, this table has to have display and use.
So if I try to compile this, we'll get table does not implement inherited abstract member, use and display.
And this stops another programmer in another department who's putting together a system using your code. That it's safety checking for them, and it's safety checking for the program, and it's the easiest way to stop, that horrible spinny message and it's saying, would you like to debug this program? It's stopped working correctly.
Right. And another thing about this though is think about it this way. You're describing your logic in a language. And these are the tools that C# gives you in order to express these things that you might want to express in your programs. And if you use these tools to express what they're meant to express, your readability, both for yourself down the line and other developers, instantly goes up because you're speaking in a very common language.
Yeah, Musaru nailed it. It's safety checking for you a few thousand lines of code later when you can't remember exactly what you did.
Right. Okay. Can an object class have non-abstract members? Yep. I could have a public void bleh on the item if I wanted to. I could also have virtual members if I wanted to. Okay. So even if item.use was not abstract and concrete code, you could still not instantiate a raw item. Yep. So even though we have a public void bleh in here, we still can't instantiate an item because it is declared as abstract. And it has to be declared as abstract because we have at least one abstract member inside of it. So you can implement them when an item is abstract. I thought abstract meant you couldn't implement it. No, you can't instantiate it, but you can implement it in objects that you can instantiate. Oh, you have a new chair, gun, and potions put into an item. Does that make them items? Nope. It means they're treated as items. It means that item, the concept of the item type, is a commonality between the chair, gun, and potion types. So they get treated as items because all three of those types understand that language. All three chair, gun, and potion types understand how to be talked to in terms of item. That being said, they're still not items technically, because if I were to do console.writeLine item .getType full name, and if I were to run this code, you'll see the first iteration we get chair, second we get gun, third we get potion.
It's a bit, see, conceptually, I find it a lot like Russian dolls. You know, the ones with the that get smaller and smaller that go inside each other?
Yeah.
And it's very much, it feels, an item has got enough space to store any of the other, the chair, there's enough space for a chair or a gun or a potion. But a chair it's not like a chair has got enough space to put an item inside it, because it's probably not clarifying anything very well.
Well, yeah, an item. I like thinking about it in terms of a contract that you can, or a language, a sub-language, and you've established this language item by writing this class, and now because all of these implement item, you can talk to these types in terms of them being an item. Okay. Is there a way to force implementations, or can you use it to force implementation of properties? Yes, you can have abstract properties. If you wanted to break an item from being used, as an example, you want the user to read book and not use book. Would you just fake the output of use? Oh, yeah. If for example, let's say that we have an item that's not usable. I would say console write line, you can't use this. However, this introduces number one reason why I don't like inheritance more than interfaces, which we're going to get into. This is not a perfect solution. This isn't a very good solution. I hate this solution, but it's what you would have to do. And once we get into interface,
that solution got bad very quickly.
Yes, but with interfaces, we can express this a little bit nicer. Sorry, is it only a way to force implementation of methods, or can you force implementation of or wait a second, I already answered that. But can a gun still shoot? Certainly. We could still add a method onto our gun called shoot, public void shoot, and then inside of it we'll do boom. And then if we cast gun or an item into a gun, and it is a gun, then we can invoke the shoot method on it. But I don't want to talk about the is and as operators just yet, because those will make a lot more sense with interfaces. Can you split the screen into 2 pages? Well, you can. I mean, you could do something like this. I'm not going to fully explain this just yet, but you can do this. What this is saying is create a variable called gun named gun, or create a variable of type gun named gun. Set it to item as gun. Now the as operator is going to say, is item a gun? If it is, return it as if it was a gun. Is item a gun? If it isn't, return null. So then on line 96 here, I say if gun is not null, if this conversion was possible, then now that I have this object inside of a gun variable instead of an item variable, remember, item and gun at this point contain the same object. The difference is they are differently typed variables. So at this point, I can now invoke gun-specific functionality on this one object.
All right, yeah, Nelson, let's be careful though on straying off too much, and NATO's very confused. Because we really should save stuff that starts getting into explanations like that that's outside the scope for open office hours. I'm just trying to keep our beginners in mind. But NATO says he just doesn't understand the code.
Alrighty, so yeah.
So try to help NATO, try to find out what it is he's confused with, because he said he can't even explain what he doesn't understand.
I was just looking at that. It's the number one thing that I found with when getting to grips with programming is knowing what to Google, if you see what I mean.
Okay. Well, okay. I can answer Benjamin's question really quickly. He asked if you have an AK-47, and I'll go back to. But maybe this will. How do you make that stop? There we go. Maybe this will make it make more sense to other people too. If I were to create a class called AK-47 and I inherited from gun, then I can choose to implement any of these if I wanted to. So I can choose to override the display. If I wanted to. Now remember, I still need to make a constructor with the base, and I'll just pass in AK-47. So I could do this if I wanted to. No, that wasn't pony music. That was my default ringtone on my phone, which I find kind of obnoxious, to be honest. Okay, so all right, so okay, well, I'm going to go ahead and pull up a whiteboard now that I said that I would do that for a while. And then we can hopefully have my mouse freeze. There we go. We can hopefully okay, so the hierarchy we have right now is we have a oh, come on, give me my brush. Hold on. I think Photoshop's crashing.
And you have a lot of problems with your computer.
My computer's fine.
Okay.
It's because when things don't happen, he just sits there and clicks the button 28,000 times in a second.
Nah.
I've got Stevie Wonder in my head now.
Okay.
The superstitions to splash screen for the beta of Photoshop 6.
So right now we have an item class. And we have a variety of other classes that are inheriting from it. So we have a gun item, we have a chair item, and we have a potion item. And all of these inherit. That means that because inside of item we have two abstract members, we have use and display, and both of these are abstract and public. Because of that, all of these classes also have to inherit or define these two abstract methods. So we also have to provide a use implementation here, a display implementation here. In share, we have to provide a use and a display. And in potion, we have to provide a use and a display. So what happens at runtime is, Nato, do you understand why it's useful, at least for us to have line 100 here, where we have an inventory, And the actual stuff inside of the inventory isn't known ahead of time. It's just a generic list of items. Okay. Well, the way that this works is that because we have a list of items, we can store guns in there. We can store potions. So let's say potion 1, gun 1, and we can store chairs. Each one of these things are objects inside of items. And each one of these things, actually, let's give these things better names. Let's call, let's call this a AR-15, an AK-47, I don't know, a computer chair. And a health potion. That's not
Iron Soul, no, they're inside of items.
You what?
Iron Soul said, now you tell me they're inside of item. No, they're inside of items.
Actually, that's a bad name for that. I should call this inventory. Now, I want to point out what I'm typing over here. This is run. That was a bad R. Really bad R. Run.
Don't worry about it.
Item time.
Just even if it's sloppy, don't worry about it. They hear you talking.
Runtime objects. So that's very important to realize that this is all during runtime, this is during compile time. So all of these things are objects, including this inventory object right here. This inventory object is a list of type item. The AR-15 and AK-47 are guns. The computer chair is a chair. And the health potion is a potion. So these are how the types break apart. We have an inventory, which is a list of item. Inside of the inventory, we can have a gun, a chair, and a potion. The reason we can have this is because gun, chair, and potion all inherit from the item base type. So now, if I was to yank out my computer chair and I wanted to invoke its display method, maybe I had code like this. Let's say so this is our inventory right here. Let's say I had code like this. I had item I1. Wow, that's not what I wanted to do. Let's call it I don't know, let's call it item. Item equals inventory at index 2. And then I said item dot display.
You've got a syntax error.
There. Lowercase I.
Don't worry about that. At this point, they should have the basic idea. I just want us to move forward because we're not even halfway through tonight's class.
Well, actually, we can. Or I mean, yeah, I guess you're right.
No, NATO, don't apologize. Continue.
Okay, so what we're doing here is we're saying item equals inventory at item or at the third index. So we're yanking out the computer chair. So this item is going to be set to this object. This object right here gets referenced by this variable because we're assigning it to the third item in the inventory. Now, the variable is typed as item. That is the type of the variable, which is this class up here. This type is the item type right here. But the object that is inside, that is referenced by this, is not an item. Instead, it is a chair. So when I say item.display, because this item.display is an abstract method, and it's being implemented by the chair, when I say item.display, what's happening is execution is going to jump to right here. This is the method that's going to be invoked. Now, if I later said something like, actually, I'm going to, so this invokes right here. If I were to say item equals inventory at 1, what's going to happen here is now I'm going to store a reference to this AK-47. This guy is going to get put into the item reference variable. So now this item variable points to an AK-47, and because he now points to this object, although the variable type remains the same, it remains item. That's the same variable type. Because remember, variable types cannot change. The actual type of the object that this reference is pointing to does change by assigning it to a gun object. And because I've changed the type of the object, when I do another subsequent item.display, instead of this display method being invoked, this display method gets invoked.
NATO, is that helping?
Okay, so is it true type, so the true type for any gun, chair, potion is item? Not necessarily. The point, there really is no true type. There's two types of type.
Yeah, this does get muddy here. It's interesting.
Use the word kind.
There's two kinds of types. There's the variable type and the object type, and they can differ. This is the variable type. And the reason item is the variable type is because that's what we said the variable is typed to. We literally said that this is an item variable. But the item variable can point to any object that implements item. So it can point to any of these items.
Right, and let me add to that. Because those items over in inventory, the AR-15 is a gun, but it is an item because gun inherits from item. So AR-15, while it is a gun, it is an item. AK-47 is a gun, but it is an item. So it is these things. Now, the computer chair is a chair, but it is an item, but it is not a gun. Because computer chairs of type, where we're starting at with an extended item called chair, and chair is inheriting from item, but has nothing to do whatsoever with gun, because gun could have some of its own functionality that relates to things a gun can do, such as shoot, reload, etc. And finally, health potion. Health potion is a potion, so it's not a chair, it's not a gun, it's a potion, But it's also an item. So all of these things that's in that item inventory list are all items, and that is why they can go into the inventory list. Because all of them inherit from item, and just the simple fact that they inherit from item makes them an item. But because of inheritance, now they're an item that's been extended. They can have new stuff added on to them. They've inherited the stuff from item, so they can be known as an item, but now with new stuff that's more specific to the type that we're trying to design them to be, such as a gun, a chair, a potion.
But the gun as an item is limited to only doing things that items can do, right? Yes. When you are referencing a gun object with an item variable, you can only invoke methods or access properties that are made available on this common base.
Exactly, because at that point, you're referencing, let's say, the gun through a type that has been defined as being an item. It doesn't know if it's a gun, a chair, a potion, or something else that's extended. That's why when Nelson put the little fancy example up earlier saying, yeah, we can still shoot the gun if we wanted to, but we have to do a little bit to verify that the item is really a gun. Because we know it's an item. The fact that it's in the inventory list means it has to be an item. But when we're working at the level of just item, then we know it has use, we know it has display, we know the things that are available at the base class item are available to us. We can't assume that the item is a gun, a chair, a potion. That would be assuming. We would have to do some sort of special code to verify that it is indeed a gun if we think it might be a gun and we want to shoot it.
Yeah. So if I go ahead and add a shoot method to gun and I try to do item.shoot,
Can't do it.
I'll get a nice little compiler error because the only thing the compiler is going to let me type in here is what's valid for the type of the variable. Remember, the type of the variable, not necessarily the type of the object. This is pretty much one of the biggest differences between a statically typed language and a dynamically typed language. So if you're coming from PHP or JavaScript, you might be used to doing stuff like this, but you can't in C#. C# is statically typed, meaning everything is verified by the compiler that there is a legal way for this code to come together before you can even run your program.
Now, real quick, James, I saw your question over there. Is there a 15-minute break coming up? And I was responding over in BuzzNet a minute ago to Iron Soul. If everybody is complete, for anyone who's completely clear on what we're discussing right now, because I know there are some of you that have been coding for a while and that have gone through like XNA 1, 2, 3, etc. Feel free to go ahead and if you've got to do something that's going to take 15 minutes, do it now, because when we're done with what we're doing here, the whiteboard, we're going to take a 10-minute break. So if we go another 5 to 10 minutes from now, plus a 10-minute break, that'll give you your 15 to 20 minutes if need be. Because I want to make sure those that are new to these concepts, because this is where it starts to get tricky for your real beginners. The real beginners who have a basic but true understanding of the simple stuff, looping and what a basic variable is, etc. Now we're starting to get into concepts that really, well, confuse our beginners. At least with object-oriented programming. So I want to try to make this as clear as possible. So yes, go ahead and take a break now if you're like completely kosher with what's going on. And then NATO just asked a question.
And is this possible because items fields are abstract? Close. It's these use and display are methods.
Correct. They're public methods that got inherited by all of these other objects. The only reason, let me point this out. This is really important. The only reason that Nelson is doing the abstract stuff is because he demonstrated earlier that in the code, one of the problems we had with the design that was going on was that we had the ability to instantiate the item, the base item class. There was nothing stopping us from doing that. And by instantiating an item class, it has no meaning. It was abstract in nature, even though at that point Nelson hadn't introduced you to the abstract keyword. It was abstract in the sense that it wasn't something as concrete as a gun. We know what a gun is. We know what a chair is. We know what a potion is. But an item, if I tell you, get me an item, I mean, that's very abstract as to what you're going to be grabbing. So to get around the problem, or to put an end to the problem of anyone being able to come along and instantiate just a raw item, Nelson made it abstract. So that fixed the problem of being able to instantiate item, which is fantastic. But we needed to assure ourselves, we needed to assure all programmers that may come in and use our API that we make available, if they're going to come in and write their own items, we need to ensure that there will be use and display, that those methods will absolutely, for sure, be on an object that someone else writes using our infrastructure that we've set up here. So if they're using item as a base class, the simple way that we can do that is we can make use and display those methods. We make them abstract methods. And what the compiler will do is say, okay, anyone who wants to inherit from item, do it. But you better implement use and display. If you do not implement use and display, I'm not going to compile. Period. What's that?
I just really love the "oh no, you didn't" voice. It's just like the compiler's going to say, "No, talk to the hand."
More or less. It's definitely not going to compile, though. It's going to say no, and that's the beauty of using abstract, because now Nelson can rest comfortably knowing that if anybody is going to extend item, it has to have an implemented use and display. So his code that uses items will not break.
Right. NATO asked, but don't we want to make sure everything has a name as well? That gets into actually the design of the program. That's up to you. Remember, you're the modeler. You're the one who determines what bit of the real world you want to model in your program.
Well, you could actually just go back over into the code that you've got there and show him. Just show him. Add a name to your item.
Well, before we do that, let's stay on the whiteboard for just a minute longer. Just going back to sum everything up that I was saying with a practical angle, the fact that list is a list of items. I'm now looking at the right-hand side of Nelson's whiteboard there. Since it's a list of items, Gavin cannot come in and say, well, you know what, I'm going to make my own item, but I'm not going to use Nelson's, I'm not going to inherit from one of Nelson's items. I'm just going to come in here and I'm going to make a golden key. And it's just going to be a base class all on its own. Now I have my own class, and this key does not need to have a display, and it does not need to have a use. I can write my own stuff into it. That's fine. But you know what? That item will not.
I've got no.
That item that he just wrote, it's not a true item that could be used in this game, because that inventory list.
I can't put it in my inventory.
That inventory can.
I can't pick that up.
That inventory can only hold items, and a gun, a chair, a potion, those are all items because they inherit it from item. So if you did inventory.add golden key, it would not work if the inventory is of type item and golden key did not inherit from item.
I want my
Sorry,
key.
man. Then you better go in there and do it right. Make your key inherit from item.
But if for instance, if item was mammal, and instead of gun, chair, potion, we had cat, dog, human. You can't instantiate. You couldn't just have a mammal. There's no such thing on this planet that is just a mammal. It's a cat or a dog or
exactly.
Mammal is an abstract.
Exactly.
And also, if you've got, then you could have a list of mammals that then put cat, dog, pony, human. But then if you had a list of ponies, well, you couldn't put cat, dog, or human in that.
Right. Now let's.
I do have one example, one code example.
Before you change over to the code example, let's look at the two questions that were just asked on the whiteboard, so that the questions panel.
This can be used for other things regarding game inventory as well, like name, string, or item weight. Yep. anything you want to make abstract, you can place on the item and force people to implement.
And then Brandon goes on to ask.
Oh, sorry. Do you say item.shoot wouldn't work even if the item was set to gun? It would. See, watch this. If I change this type to a gun, you know what's going to be funny? Right now, this line has a compiler error. Okay? Everybody good with that? This line has a compiler
error. If you leave item
now,
there.
Yeah. If I leave item here, now that line has a compiler error. But watch this. If I change the variable type to gun, this compiler error actually goes away. But
you made some very
this and this actually, hold on, give me my red.
Nice.
Come on, go. I have my tablet constrained to this one monitor, and the OK button was all the way on the it's frustrating. So right now, this and this have a compiler.
Very good.
And this is OK. And the reason is we cannot implicitly convert an item into a gun. Because although a gun is always an item isn't necessarily a gun.
Exactly. That's the key thing, what you just said right there. An item is not necessarily a gun. Could be a chair. Could be potion.
Yeah, like you see right here, we say gun item equals inventory at 2. Well, in this example, a computer chair is in the third index.
And take a look over on the left-hand side, compiler side. If we look at chair, it's inherited use and display, but it sure doesn't have shoot.
Right. So there's no way for the compiler to know that these two conversions are compatible.
And we will get into a detailed look a little bit later on at a couple of different ways that you can go about making this work right. Nelson's already thrown up one example quickly earlier, but I don't want us to get bogged down into that right now. This isn't the time. Right now it's just getting a basic understanding of what's going on with base objects, parent objects, child objects. And a couple more things have come in. Oh, blood!
That was not expected.
Take care, Matt. Have a good one, man. Good night.
Okay. Okay, and then the first item.display would pull from the gun, not the chair. Well, it would. It's not. You can't. The code just want to compile. The code just want to compile, and if you coaxed it into compiling, which you can do with casts, you would get an object conversion exception at runtime on this line. Okay. So can I do
yes,
a
now you can.
bit of code?
Sorry, Nelson. Just
okay.
Oh, Wolfray says we've only got 4 hours left because he's got to go to work at 10.
Okay, what I'm going to go ahead and do is I'm going to show something that I'm stepping out on a limb right now. So be very afraid. But I think it might help some people. I really do. There's a good chance that it will. And if you get more confused by watching what I'm about to do, then just ignore
take 2 steps back, turn to the left, and vomit.
But please try to understand what I'm about to do. What I'm going to show you guys is a design pattern called the template method.
Oh, boy.
Okay. So let's go ahead and define an abstract class, and we're going to call this the...
Rhythm.
Huh?
Hang on. No, let's not mess Nelson up. He's got an idea in mind. Go ahead, Nelson.
Let's call this a even number generator. And it's going to have a public void run with an int min int max. Then it's going to have a public abstract void process number method that takes in a number. So the public abstract void process number method, which takes in a number variable. Now what I'm going to do, the reason why this is called a template, the template class or template method pattern is that I'm going to write an algorithm inside of this run method. I'm going to say for int I equals min, I is smaller or equal to max, I plus plus. And then we're going to say if I modulus 2 equals 0, then we're going to invoke process number of I. Now, what I have done here is I have written another algorithm, and I am being serious when I say that this is an interesting algorithm, because this could be a variety of things. Imagine that you wanted to write code that, or imagine that you were doing something even more interesting, like looping through the files on a file system or in a directory. Or imagine if you're grabbing things from a database and performing operations on them. This is important. This is the algorithm. But we've decided that we want to reuse this algorithm over and over and over and over again, and we want to do different things with it, with the results of the algorithm. So what we've done here is we've created an abstract void process number method that takes in an int number. Everybody who inherits from even number generator must provide an implementation to this method. And when it does, every time line 16 executes process number, the implementation from the child gets executed. So what I can do here is I can create a class console even number printer, and I can have it inherit from even number generator. And then notice that because this is abstract, I have to actually provide an overload or a override for this. So I can say public override process number, and I can say console write line even number blah. And then what if I wanted to do something else with this algorithm? I can say file even number printer inherits from even number generator, and I can say public override process number, and I can say console.writeLine pretend this is printed to a file.
Autocomplete problem on line 28.
Line 28. Oh. Ah.
That's what you did.
Okay. So what I'm going to do here is I have two classes that both inherit from even number generator, which does some sort of intense calculation, and I want to reuse this algorithm over and over and over and over again. So now all I have to do is create different classes that implement even number generator and provide an implementation for process number. So now if I say console even number printer and then file even number printer, I can say printer dot run, let's say 1 to 200, and I can say printer2.run 200 to 500, and then I can go ahead and say console read key. And now if I run this program, you notice that a bunch of even numbers get printed out. So what I've done is I've used inheritance and abstract members together in order to make a algorithm that I can reuse over and over and over again. And this is an actual codified design pattern called the template method.
Is that a Gang of Four one?
Can't remember. Probably. It seems classic enough.
I could look.
I mean, Jason, do you think this was a good example?
Yeah, no, it's fine for those that were able to follow along, but it's, well, go ahead and take a look at what's coming in over on the questions panel.
Okay. Sorry, no, you said I am shoot would work, but it would also be a compiler error. No, it would be a compiler error, which means it wouldn't work. When you abstract out process number, do you have to provide the overload with matching overloads in the child classes? Abstract out process number. Yeah, I have to provide the override in both of these overrides, because these are overriding an abstract method. So now let's go ahead and jump into printer, and I'm going to hit F11, and we jump into run. So now that we're in run, let's watch what happens when I get to process number. When a process number gets invoked, our console even number printer's process number gets invoked. But now, if I were to jump into printer 2 and hit F11, when its process number gets invoked, the file event or file even number printer gets invoked. Can you leave that off in the abstract part? I don't know what you mean. Line 21. Yeah, you have to provide a complete method signature. Yes, the overload does matter. So this abstract is of this overload. I could create another process number method that isn't abstract, but has a different overload. Sure. Okay. So Nato, did that further confuse you, or did that maybe solidify something, at least as far as how we can use inheritance and abstract members to do something interesting, and how we can take advantage of the behavior that it doesn't matter what the variable type is that we're working with, even though we're working with the right types here, they don't necessarily have to be, but how by invoking the run method, internally, the process number method of the corresponding objects gets invoked.
You might want to also explain what the Gang of Four is, just for the people that are...
Yeah, the Gang of Four, it's the four guys who wrote, I believe, the first book on design patterns, and they kind of compiled them and gave them the name and wrote this book that describes a variety of different design patterns that you can use in your code.
There's a Wikipedia link if you want to take a look. I
already put.
Oh, I'm sorry, I didn't see. It is definitely a class that I wouldn't mind having at some point, and having students actually get the book, and we use that as the actual book for the class.
And actually, NATO, they come from architectural design patterns. The idea was used there first, so it's probably something you're familiar with from that.
And it is, by the way, Nelson, it is a behavioral pattern, the template method.
Well, yeah, that's still a
No, I'm saying it's part of the Gang of Four. No, I was just listing off on where it was at.
Okay.
Defines a skeleton of an algorithm as an abstract class, allowing its subclasses to provide concrete behavior.
How easy a read is their actual book? Is it very academic and dry?
No. I didn't find it. Then again, I'm weird.
Yeah, it's all the codes in C++.
Is it? I thought it was in Java.
I thought it was C++. Maybe I'm...
Sorry.
No, go ahead.
I would highly recommend a book that Segfault put me onto, which is Design Patterns for Dummies, one of those big yellow books from the For Dummies series. It's really clear, and it does go over all the Gang of Four patterns, plus it mentions, is probably the best way to put it, some newer patterns like MVC and so forth. But and the code examples are in Java, and thus very readable if you know.
Well, let's keep kind of on track.
All right. So did anybody at least enjoy this example, or did I just end up confusing everybody
Gang of Four is
else?
all C++.
Oh, it is. That's disappointing. NATO.
It's funny, I was able to reach right over about 5 feet from me and grab the actual book. It is a superb book, though.
Yeah. Okay. So yeah, just back to this. Let me go ahead and make this code, or this imaginary code, compile again with our imaginary compiler.
Sorry, that was just funny.
That's an abstract idea.
Yes, it's very abstract. Okay, so how is everybody with this diagram at least? I mean, the biggest thing to take away is the differentiation between the variable type and the object type. The variable type could be anything that's convertible into the object type.
I mean, let's take a look at the syllabus real quick. As a matter of fact, though, right now now that you've summed that up right there and made it compile, let's go ahead and go on break because it's now been an hour and 35 minutes of straight recording without a break. And then after 10 minutes, let's go ahead and pick up and continue. But before we hit break, I just wanted to say real quick, Nelson, you know what all left we've got to do tonight. We can always call it right here or sum up after we get back from break and extend the entire course by 1 week if need be.
I'm not against that at all.
I mean,
that would give me time to actually build the.
You guys would not end up with less. You guys would end up with more because, well, if we did another class, you know how that would go.
Because then the next class we could spend like the first hour and a half going back over this and interfaces, and that'll leave plenty of time to go over everything else.
I mean, this 102, I promise you guys, is an ambitious class. That's why I was pretty excited about it myself, because we're going to be covering a lot of cool things. And tonight, we still have to get into some things that are going to be very important. And I know like NATO's extremely tired right now. So I wouldn't mind this. If we want to take a break, come back from the break, we can keep going. But how about we keep going on just making sure people have an understanding of all of the concepts that we're working on right now before we dump an entire new bucket of concepts on you.
I mean, yeah. Although I think people might start be getting tired, but I'm up for hanging out as long as people.
But let's take a break. While on break, you guys in the classroom discuss it, and yeah. So I'm just going to go ahead and hit pause now because I've been babbling. All right, we have resumed the video recording, and let me start out by giving a quick explanation of what we're going to do. And for anybody who gets upset, please understand right out the gate that this is just how we do things at 3D Buzz, and I understand that that's not for everyone. But I am more concerned with people understanding the concepts than trying to just quickly cram everything in and move on. And what we're going over right here in week 1 is the foundation for the rest of the entire 102 class. As a matter of fact, it's going to be the foundation for everything, for everything from this point forward. It's critical stuff. And we've got some people that have had some difficulty grasping the concepts, and, it's very understandable tonight. And so I'm more interested in us making sure that everybody understands that, as opposed to getting into the BCL stuff that we wanted to go over, and then into the state machine and the idea of the state machine or a state system, and going from there. 'Cause there's still a lot to do tonight. So what we're going to do is we're going to add one more week to the course, and which will result in more content, I am sure. But we have a different homework assignment that we're going to be going over here in just a second. And this is what everybody will do for the first week. And then when we come back next week, please feel free to join us on open office hours and discuss any problems or confusions that you may have after going over this video again if need be, and let us help you. But then next week, and we'll make adjustments to the syllabus as well so everything reflects properly. We'll do that over the next day because we've got a lot of stuff going on. But next week we'll just pick up and continue with the new BCL stuff, and then getting into the state system stuff and going from there. So with an understanding of that, let me go ahead and turn this over to Nelson to discuss what the homework is. And then once we're done with this, I would like to just jump back. That means everybody who feels comfortable can leave. And for anyone who would like any extra time, we'll make it available.
Can I just, before he starts on that, double check then? So does that mean that it will be the following week, which is the 7th of June? 7th of June, Thursday the 7th of June.
Yeah.
You're here that week. Well, you must be, because that's week 8 of the C++ class. Okay, I shall, while Nelson's explaining it, I'll pop it into the calendar system.
Don't pop it in yet, because right now I got to see about editing the actual webinar itself. But first, let Nelson go over this, and then after that, for those that are new in the programming course, I'll have you discuss how homework needs to be submitted, because we have people in the class that have not submitted any programming homework before to you. And then from there, we'll go into any additional help. So go ahead, Nelson.
Okay, so for the homework, go ahead, create a pet class that has abstract functionality, at the very least 3 methods. At least one of the methods must take in parameters, and at least one of the methods must return a value instead of printing things out to the console. I kind of want to make things more interesting than just people having methods that print out bark to the console, for example.
Now, do you want to specify that the pet class should also have a constructor that takes in a parameter? Because then they'll have to do constructor chaining, at least basic chaining. That just means they get their fingers dirty with everything we've talked about tonight.
Okay. Create an abstract pet class that has abstract functionality, at least 3 methods. It must have a string name read-only property that is filled by a parameter to this constructor. At least one of the methods must take in parameters. At least one of the methods must return a value instead of just simply printing things out to the console.
And Nelson, Barry's right. I don't think you've covered read-only, so just take the read-only part out.
I mean that in a literal sense. I mean a public getter and a private setter.
Oh, okay. That we have covered.
I don't mean the read-only construct. Okay. I mean, yeah. Create 4 implementations of the pet class that will appropriately implement the different methods. Allow the user to enter 0 to many pets, can be any type, and store them into a list of pet variable, or object's a better word. After the user is done entering the pets, allow the user to select a pet, perform an operation. You will have to collect the arguments required to invoke a method that has parameters, and then repeat A through B until the user decides to quit.
Could you just clarify that you will have to collect the arguments required to invoke a method that has parameters? What do you mean by collect the arguments? From the user from elsewhere in code? Or?
So that they're not just passing in constants into those methods that take parameters.
Yeah. And CTOR is constructor.
Segfault, I would say that's up to Fat Guy, but I'm pretty sure he's going to say no.
What did Segfault say?
Can we use multiple source files?
Well, if it doesn't actually matter.
If we're not doing the basic framework thing, then yes, absolutely. So we also need to go over how homework is to be submitted. This will be written up and put into the forums, though, and a link will be made available in the calendar. So if there's no questions about this, we need to talk about homework submission.
Yeah. Well, Nelson, if you could just go to the member sponsor lounge and bring up the master thread of instructions of joy.
Yes, of joy. Where are they again?
Top of the list.
This one? Or no?
No, the one at the top of the list.
Oh, see, I always ignore stickies.
Well, that's silly. Yes. Read this, do what it says. That's essentially it. I told you I wasn't a very good teacher.
Nice.
It's all there. Read what it says, do it. Set up a Dropbox account.
Yeah, okay. So everyone here can read. So read this and do it. There you go, Gavin. That should be helpful for you. But this is where to find that information. Again, if you back up one, Nelson, just go to the Member Sponsor Lounge. It's the very top thread in there.
Which is going to be ignored by everybody on
Yeah,
First
but not
Glance.
now because we are specifically pointing it out. And, Gavin, when you write up the homework that the link will appear in, point to this.
Yeah. I always cross-link
Thank you.
everything.
There we go. Perfect. So there's the homework. There's how to submit it. For those of you that are exhausted and you want to leave, feel free. Thank you for hanging out this long.
What I will say that relates to that is the steps to get set up obviously involve PMing me an email address. Please, and I have had messages saying, I sent you my email address, but I haven't had anything back yet. It's just more efficient that way. So don't expect it to be like 5 minutes later you will be set up. It may be a day or so before you get. But
Daniel said,
Yes,
what about the
Dropbox will
format
tell you
of the
immediately.
code? Talking about zipping the...
No, just inside your folder you will end up with the newer. In fact, all of the C# ones will end up with subfolders inside them saying week 1, week 2, week 3, week 4, week 5, week 6. And you just make sure that you've copied across your... yes, thank you, Bazza. You've copied across your solution folder and obviously the solution and everything else that's inside it into there and synced it before the due date. And that's it. You've submitted it then.
How's that been going, by the way?
How's what been going?
The Dropbox solution.
Yeah, it's good. There were a couple of kinks, but there's nothing unfixable. And I wrote a little parser for parsing all the PMs out via XML, which is joyous.
And
The instructions are going to all be in here, I believe. They do talk about zipping, right? Or
No zipping required.
Oh.
It says there under submission, just it's gone.
Actually, code's pretty light. I doubt you're going to get more than a few hundred megs for an entire course, if that.
And then take a look.
The Blender
Take a
might
look
be
over in
different.
the questions panel, Gav. Make sure that you've catch all the questions that have come in.
What about the format of the code? Rename the programs. No, none of that. Just make sure, because the whole way this is set
Now,
up.
remember, when
now,
you say none
I've
of that,
just got
they're
a
not
folder
sure.
for
They're
each
not sure which
person.
one you're talking to.
Oh, well, really, we don't need to rename the programs. Yes, you don't need to zip the folder, just as it is. Inside your, the folder that is generated with your solution in it. Just copy that across into the folder in Dropbox. One thing I will say though is, due to space considerations and a couple of unavoidable things with the way Dropbox works. And I was talking to Chris about this as well. He's probably going to be doing the same thing for the UDK, which is at some point soon after the deadline for the homework, it will be moved out of your folders to elsewhere on our systems, which means don't do your homework in that folder and expect it to still stay there, because it will go away. Although I believe you get the option to undelete it at your end locally, But yes, do it somewhere else and then copy the folder across. And everything should be golden. Shiny.
Okay, anything else?
What happens if someone wants to be a jerk and puts a 5 gig file in there? They probably get banned.
They would be immediately kicked out of the class.
I get banned from the site if I get my way. Well, my bandwidth, I don't want that happening. Any more questions on the sort of homework logistics? Doesn't look like it.
Okay, good. So we've got to get that done up. Now, let's go ahead and jump back for anyone. Giving that over to Gavin. Okay.
Yep.
And okay. Now, good night, gentlemen. For those of you that want to leave out, for anyone that has questions or would need other examples or anything, we're making ourselves available now for just that. And if everybody's absolutely dead, then that's cool too.
And see everybody.
Yes, bye, guys. Those of you that are heading out. Good night. And thanks for hanging out with us for so long.
People. Wow, everyone's
Gavin,
going bedtime.
Gavin, question over in the questions panel for you.
What? Where? Will we submit the entire project? Nelson, can you show what the solution folder, please?
No. This is what you want to grab over, and so let me get this straight though. You create the folders for people to dump their things in, Kevin? Like week 1, week 2, week 3? Or do they do that? Now I'm confused. But this is your solution explorer, or your solution folder.
Yeah, if you got one level from where Nelson is into the projects, grab that folder and drag it into your Dropbox folder, which will, for all the ones that I'm creating, it was only the first batch of C++ that didn't have subfolders in saying week 1, week 2, blah, 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 because I only thought to do that.
Like
today.
Jen said, correctly named, of course. No, well,
Sorry?
like Jen said over in BuzzNet, correctly named, of course. Instead of console application 6 or 126 or...
Well, provided you put it in the right place, there will be a folder in there saying week 1, week 2. Provided you put it in the week 1 folder, you can call it giraffe hockey if you'd
okay.
like.
I see how you want it.
Yeah.
Okay. All right. Back to Nelson. Then back to anybody with questions. Back to object-oriented programming. The reason we're here to begin with. Or is everyone dead? We have killed our students. That's horrible.
Let me just go and turn the lights off because they're no longer required. There we go. Actually, in all seriousness, it's daylight now.
Sorry, guys. So, yeah, NATO. Anyone at all with questions?
I understand the concept, but we do need to place abstract at class and at the method level to make something abstract. The answer is yes. Now, you will have to put it at the method level, obviously, because you can still have normal methods within a class. even if you have other abstract classes. But the way that C# works, and this isn't true for C++, for example, but the way C# works is that if you have any abstract members, you must also add the abstract modifier to the beginning of the class. Otherwise, it won't compile.
And remember, abstract classes cannot be instantiated.
C++ doesn't have an abstract modifier. No, it doesn't. A C++
Let's try to stay on
method.
C# if we can. We have had feedback from students saying, please be careful with using the discussions on how other languages work, especially right now with it being this late and we've got some of our beginners struggling trying to understand. We can save that for C++ class talk.
Can you just have a list of things that animals can do and have them be numbered, and then have the user pick the number for what they want the pet to do? Yes, that's acceptable.
NATO, remember, question panel, my friend, question panel. That way it's sure to be seen.
The method ble is callable via chair.ble. Yes. For example, if I was to instantiate a chair, just a normal chair, just a normal chair,
With an I in it.
I can access the ble method, even though the ble method is technically on the item class. It gets inherited by the chair class.
Back up to chair dot. You can see which ones it's got.
Yeah, ble, display, and use. And then, of course, equals get hashcode, get type, and toString are all provided on every single object in .NET.
Because the base of all objects is object.
Yeah, actually this right here is turned into this. I'm not even kidding. That's how it works. If you do not specify a base type, you automatically get a base type to object.
Everything's something.
That's where
And that something
that's
is
where
object.
some of that magical stuff like toString appears from. Uh-oh, NATO just had something click. Sweet.
That's the thing. A lot of these things have all been going on behind the scenes with a lot of, particularly all the console and in parsing and string parsing stuff has been going on behind the scenes. But this is why it's so fundamental. This is why we're spending so long making sure people are clear on this, because it is fundamentally the way the thing works.
So, Nelson, we had a question from Ryan a minute ago saying, is there another simple example that we could put together?
Another example?
Over virtual
You're just
members.
making stuff up on the fly, and so we're not trying to come up with homework now. So just, this is what Nelson's generally pretty good at, pulling code out of his butt. And Jen, yes ma'am, we are still recording. Even while Nelson pulls code out of his butt. And like Ryan just said, have fun, Nelson.
You just reminded me of a movie I told you about earlier today,
no.
Jason.
Which one? Oh, no. Yes, I remember.
Right. Meanwhile, back in code.
Okay, anyway. So, I don't know. Virtual members. Why would you ever need a virtual member?
I don't know.
Yeah. Actually, I don't really use virtual members all that often. I generally will use abstract members or interfaces. So, but I can show you what I would use an abstract member for, and using a virtual member, then show why virtual members are better.
And also you can see what Ty said over in the questions panel, because he's something that he'd like to see that could be helpful.
Okay. Well, let's say we have a graphics card class. And then let's say we have a computer class. Then let's say we have a CPU class. And let's say we have a, motherboard class. And a computer class has a graphics card a CPU, and a motherboard. And I'm going to go ahead and make these properties, because they really should be. And then I'm going to inject them in via the
And
constructor.
all of that was covered in 101.
I don't know why I'm trying to type in that U there. Graphics card, CPU, motherboard.
And again, as obvious as this will be to a lot of you, to those that may still have just a little bit of difficulty with constructors, we're using a constructor inside of computer because if we didn't, and if, let's say, we made our graphics card, CPU, and motherboard all public setters and getters, somebody who instantiates the computer class could forget to give the computer a graphics card, a CPU, or a motherboard. And we all know what happens if we try to build a computer without those components. We don't get a functioning computer.
It turns out like
yeah,
Nelson's.
really. We don't get a functioning computer. By having the constructor require these three things be passed in, you cannot instantiate a computer class into an object without supplying a graphics card, a CPU, and a motherboard. Very important.
Yep. So let's go ahead and create some public virtual void render. And then the CPU will have a public virtual void compute.
You can do it, Nelly.
I can't type anymore.
I have faith in you, Nelly. Do it, man. Do it.
Do stuff. Motherboard does stuff. Okay, so now we have 3 classes with virtual members, and we want to go ahead and create concrete implementations of these particular these particular classes and pass them into our computer object.
Now,
so that our computer
the
object can run.
terminology that Nelson is using right now is extremely important in your journey to learn object-oriented programming. The concrete. If you don't mind, Nelson, explain what you mean when you say the concrete.
Well, as of right now, these are technically concrete classes because they're not abstract. But what I mean conceptually is the concrete classes, which are the real classes that are in charge of performing behavior, not the classes that are more abstract or virtual in nature, but the concrete implementation or the real implementation of a particular given object. Okay, so each one of these has these 3 things, and then we're going to have a public void run. And when we run our computer, the first thing we want to do is compute something. Then we want to render something. And then we want to do stuff with our motherboard. So very straightforward. So now let's go ahead and create implementations of each one of these classes. So I'm going to start with an NVIDIA graphics card. And it's going to have a public NVIDIA constructor that takes in series. Now it's going to override the render method. And when it renders, it's going to say
Oh, come on. ATI comes with a free BSOD.
I thought you said ATI comes. You said ATI comes with free beer. I'm like, what? I'm ordering ATI right now.
So then we have our graphics card. Let's give it a CPU. Let's call this an Intel CPU. And we might have a few different parameters to our constructor. We might have, like int cores, string series.
You just better have a an ATI that says it's better than NVIDIA?
Nope.
Because this is being recorded. You get someone from ATI's legal department seeing this, going, actually...
Okay, so now we have our CPU and our graphics card. Let's go ahead and do our ASUS motherboard. And it'll have a series, and I don't know, let's top, whatever. Maybe we can throw on private string CPU socket or something. And what am I thinking about? That's not ATI anymore. That is AMD.
That's true.
And then we'll have our public override do stuff method that says doing stuff with ASUS Mobo CPU socket. Okay, so now we have 3 concrete implementations of our graphics card, CPU, and motherboard. So now let's go ahead and instantiate a computer and give it implementations from these 3 classes that we've created. So I can go ahead and say computer equals new computer and pass in a new NVIDIA graphics card. Let's give it a GTX 500. Let's pass in a new CPU, a new Intel CPU. Let's say 4 cores, or 4 logical cores anyway, and call it the i7. And then instantiate a new ASUS motherboard. And it's the, forgot the series of mine, so let's just do stuff. And then let's give it a CPU socket of LGA, oh great.
Things.
Help me, Jason. 1333? Is that what it is? 1733? Oh well, I can make up whatever I want.
Yeah, because that's the key detail in this that matters most.
Of course. 1336. That's what it is.
1664. Okay. Oh no, that's still Artois.
So now we have our incredibly biased computer, where we have an Intel CPU, GTX 500, and a stuff. And we can do so because each one of these classes that we're instantiating is ultimately a different implementation of one of these base types. So that's how these virtual members work. If these members were not virtual, then instead we wouldn't get the same behavior. If these methods were not virtual, and we did not have the keyword override on each one of these, what we'll get is nothing. Actually, we don't really get nothing. You'll notice that each one of these methods do get invoked. The CPU gets invoked, the graphics card gets invoked, and the motherboard gets invoked, but that's not what we want. We want the specializations that we've declared inside of our Intel, NVIDIA, and ASUS classes. So that's why we add the override and the virtual keywords. If we did not have these keywords, then things won't work properly. But because now I've added the keywords back, you'll notice that the correct methods get invoked. Do you have any more questions about virtual members, Ryan?
Oh, you said Ryan. It sounded like. Do you have any more questions about virtual members, friend? Very kind of old West fashion.
Okay. Can you use another example of constructors using inheritance reference base class? Yes. So for example, our graphics, actually our CPU, something we know pretty much all CPUs have is amount of cores that a CPU has. So let's go ahead and say public int count of cores, get private set. So basic automatic property, read-only automatic property setup we have here. Now let's give it a constructor. Let's say public CPU int count of cores, and let's say count of cores equals count of cores. So now, because I've declared a constructor here, the class that inherits from this type, it requires that I pass in or fulfill the constructor that's parameterized on the base class. And that constructor is this, which is currently the only constructor in this entire class. Therefore, it must be invoked by the base or the child class's constructor. And the syntax for doing so is by placing a colon, typing in the keyword base, and opening up parens and passing in parameters. So let's go ahead and pass in our cores parameter. And now that we've factored out the amount of cores from our child type to our base type, I can delete this field. And instead of doing underscore cores right here, I can do count of cores. I can access that property directly from the base class. So now I can go ahead and hit F5, and you see I get an Intel CPU, a Series 4 with i7 cores. But you get the point. What's that? Included IO stream. That's awesome.
And hurrah, Wick. He put click, got it.
Awesome. Any more
Well, that's good, because that's a fundamentally good thing that we did sit here for this time, and
that's why we're doing this. Like, yeah. I don't mean this in this particular instance. I mean this in a very general sense.
This amount of hours.
Scroll down for Jen a little, if you can.
Yeah.
Also, go full screen if you can, also.
Can't do that, Dave.
Thank you.
That's almost the right voice as well.
Bruh.
I can't do that, Dave.
Yeah.
It's actually not a compliment to say that somebody can say something in emotional monotone.
So yeah, the question is, I wasn't a member sponsor while the 101 class course was available. I'm sorry, while the 101 course was going on, is it still available to view? Yes, absolutely. All you need to do is go back to the calendar and back up. Later we'll come up with an easier way to get to older classes, but in the calendar you can back up to where we first started it and just go through each of the classes. It's all there. And you're welcome, sir.
Wolf, okay, so he's actually talking about, so sorry, Jen, I'll go back to that in a second. I just need to answer something for Wolf. He asks, why would you want the abstract class to have a non-abstract method like that? Bleh. Shouldn't bleh at least be virtual? A method should not be virtual unless you intend for the behavior to be overridden. That's a very important thing about object-oriented programming. There's actually an interesting article, it was either John Skeet or Eric Lippert, who talked about the design decision to not make every method virtual by default in C#. And their reasoning was more about you should be explicit about those sort of things because there are members that do require everything to be just right for them to work. Now, as much as we love to write code that is very robust and stable, the fact is there are a variety of times where we write code that depends on a very specific set of circumstances before it can execute properly. And by allowing people to override the methods in your base class, you are opening yourself up to a situation where your class, your original class, your base class, is making assumptions about how those methods work. But another person, the child, is actually changing the definitions of what those methods are. And you'll run into many situations where you will inadvertently break otherwise functioning code because you overloaded or overrode something that shouldn't have been overrode, or you didn't keep everything in mind about what that method should exactly do.
It's always better to say you must do this than to say, yeah, you can do this if you want. Because then people will do this if they want or not and end up breaking things.
Yeah, and in particularly, so yeah, you wouldn't want, you don't need to make every method that you write virtual, because that'll break things eventually down the line. Now, why would I want this method blah right here? Well, frankly, I wouldn't. And if I didn't, then I could have this be an interface. But we're going to be talking about interfaces next week. The only difference between an interface and an abstract class is an abstract class can have methods with some functionality on them. Well, and also you can inherit or you can implement multiple interfaces.
Let's not get too far away.
That's next week.
That comes up next week. Hooray! Back to this. More questions!
Can you overload a virtual abstract method? Yes. What the hell's going on there?
Roommate's doing something bad.
Do you hear the ceiling shaking?
Well, no, I don't hear the ceiling shaking, but I heard something.
Bad pictures, bad pictures.
Don't worry, none of them are into ponies.
Wick said, a virtual abstract method?
There's no such thing. You can have an abstract method or you can have a virtual method.
Thanks, NATO.
I just got it. That took a while. Jeez.
Anyone else? Guys, questions? Ladies?
Questions.
So shall I start writing a test on virtual and abstract then?
It's not a bad idea.
With the quiz system? If everybody knows all this stuff, we can throw a pop
Yeah, we
quiz
can
at
do
them
pop quiz
next week.
I like it. Gavin, I say yes. That's a great idea.
I'm just waiting. I'm quite surprised to see no. No!
No, everybody that's in this class should be in the class because they really want to learn this stuff.
I'm surprised as many people stuck around.
Anyone that's still here really does want to learn this stuff.
Nelson, I agree with you. I'm really impressed. Because some of the people that we have here right now, like poor Segfault, has been here for, 10 hours now?
Yeah, he did the UDK as well, and we were doing stuff before that.
9.5 hours.
I am very impressed, sir. Very impressed. All right, Nelson Wick just said something over in BuzzNet.
Virtual can be defined and available for overload, whereas abstract by itself has no definition and requires being revisited by its children. Yes, that is the biggest difference. Well, not revisited, but overridden. Or
revised.
Yeah, hold on. Overridden. Yes, it's overridden. Override and overload. I used to think it was funny that people got them mixed up, but then when you say the words override and overload for a 4-hour programming course over and over again, you really start to confuse them.
Particularly if you start overriding, overloading methods.
Which you can do.
Indeed.
And NATO just fell out of his chair.
All right, well, I wonder if you can pause the video. I can step outside and see if anybody else has any questions.
We shall. And we're now back from our regularly scheduled break. Are there any questions over in the questions panel?
Okay.
Nelly.
What does it mean when it says for the homework, you will have to collect the arguments from the user required to invoke a method that has parameters? Basically, what I want to avoid is I want to avoid people writing programs like this, what I have already demonstrated, with just console write lines out. I want people to write methods, abstract methods that take in parameters, and then I want the user to be able to input those parameters into the program when invoking the methods on the particular pets. So I want the user to have to be able to actually change the parameters that are passed in, so that you're actually performing a computation instead of just console write lining out or passing in constants. Oh, got all silent.
It did. NATO's on Facebook right now. NATO, get your butt back over to the class.
That means you're on Facebook.
Heck yeah, I'm monitoring what my students are doing.
Well, let's get your
no,
back
I'm
up.
listening.
Oh, yeah.
Keep an eye on the
right.
students or passing notes or on Facebook. Dual monitors. I don't care.
I need more monitors.
I've got 3 and I need more.
I really do now. I've only got 2, and with webinar, and now I'm going to want to be coding along with this one. It's going to get impossible.
I would like another monitor, or 2, or 5.
So are we? Yeah, bigger blue screen of deaths. Is this degenerated into us just gibbering now? Or
Yeah, if there are any other questions.
Has anyone else got questions?
Wolf does. Do you mean like adding in strings as parameters? Yeah, or you could have like a method that does like what I had before, where calculate salary took in a parameter for the year to calculate the salary for. I just want to force people to actually write methods that have some sort of computation inside of them, and the computation that you put inside of the method is up to you. But just outputting something out to the console is a little bit boring, so I wanted to sort of get people to think about how you could write some calculations. If you wanted to make a pet run, how would you do it like that? Well, you can change you can change your specification. You can say, don't make the pet run, ask how fast the pet can run, given a particular distance or type of terrain. So instead of having the method perform the run operation, you would have a method that actually gave you a calculation that would indicate how well they could run given a particular condition.
That'd be cool. You could have run that takes in a parameter called forest.
D&D Games asked, actually a question that's completely irrelevant to the course. What happened to the radio talk show? It's pretty much in it right now.
Yeah.
Yeah, we've been so swamped with classes, designing and then teaching them, that we haven't had time for doing that. Though when we finally get back around to having one, it should be awesome. I'll just have to have a margarita machine installed in the room first.
Ooh,
yeah.
Just give me a bottle of Hunter and I'll
Best
be good.
radio show ever.
I'm going to hide from that class.
I totally think we should do
Another
Unity crash. A drunk Unity crash course. That'd be lots of fun.
totally unprofessional, but as long as people knew that ahead of time, yes, it would be funny.
Yeah, it'd be like on the weekend or something. It wouldn't be like a scheduled thing.
It's horrible.
Well, we should. I think we should do the kind of 3D Buzz Pro short course, which was essentially involved the sort of schedule that Nelson maintained in coding up BuzzNet. And you basically lock everyone in a room with a computer and like a drip feeder of water, and instructions to write an internet.
Well, so fast, slow, and like that, yeah. Yeah, you could enter 1 for slow, 2 for fast, or you could use an enumeration.
Which we did cover in 101.
Enumerations are great, but I like Java's enumerations more than C#, and it pains me to say that, but it's true.
And of course, the natural thing that goes with enumerations is switches, and you hate those as well.
NATO, you're over there liking other people's stuff on Facebook, but you don't like my comment about our C# students are awesome. What is wrong with you? That's better, Nelson.
Oh, well, you see, he's British. It comes under the self-aggrandizing thing because he's one of the students.
There we go. Now we have some students that appreciate it. All right, this is completely outside of the C# thing, so pretend it's a break. Dave asked if you could write an example of a Java enumeration. Nelson?
Not off the top of my head. I haven't actually written one, but I've read about what they can do. I can pull up.
So you're just being a fanboy?
No, it's not being a fanboy. I've read about them. They can have what they can do is you can put methods on enumerations. So, for example, oh, come on, work Windows key. So, for example, you could have something like enum pet even, and you could give it like a something like a. Not only can you give it methods, but hold on. I need to get this. See, the syntax is what I have never done before.
Such a noob.
I don't write Java. I just read about it and got really sad that C# didn't have it.
In all seriousness, I'm going to crash out relatively soon, I think.
Wick, nah. I think we're at just about the very end, though. People will hear how we just digressed into just a bunch of bumbling fools.
Of course, we've got to make something really important point that we never ever mention again.
Voodoo Hoodoo, we didn't need to know about the toilet. Take care, man.
How do you imagine his toilet?
I'm not even going to imagine that. What's wrong with you, Gavin?
He needs to take. Well, no, you said take care. It's like, okay, right? You're like, don't forget your machete. And if you're not back in a week, we'll send in the mountain rescue. No, NATO, not those again. Dear God, have we still got that? The screenshots of that. In fact, you recorded that.
Yes, I did. Yeah, come on. Those were. I still got to get that video.
That was
I
fantastic.
did a private C# lesson for NATO where I taught him in my street style the way I would teach at the Renaissance Center, which was very different than the way I teach here.
All right, so if Java enumerations were available in C#, this is what they would look like. I'm basically creating a class and then creating a variety of instances for the class and using the constructor that I defined right here. So it's a very, very interesting concept.
Yeah, that is interesting. NATO, you'll have to explain. Yeah, there you go. It involves very unusual examples. Okay, that's good. Yes, crude.
And then Dave just did a little example of what you can do with them as well. But they're like, you what?
Doesn't matter.
That's crazy. That's cool, though.
But yeah, so being able to define like a bunch of instances like that is really cool. F# enumerations are even stranger.
And with that, I will go ahead and conclude our video. Well, we don't have to stop the webinar. But thank you guys very much for joining us tonight. It's been absolutely amazing. And welcome once again to C# 102. We'll see you guys most likely Wednesday for open office hours. Everybody take care. We're out of here. Goodbye.